Okay, hey, hang on, let me start the video here. Okay, brighten up a little bit. Great, great. Yeah, good to see you here. Well, we'll wait for the rest of the regulars to join us. And I'm glad that Eddie is here. Okay, good. Eddie in some weird time zone hasn't had a lot of sleep, I assume. But I want to pick on you because I saw your blue the Reddit post in the blue Reddit. So I think the two of us should code together today. Because we're going to start coding today, right? Well, it's not like rejoicing that there's no more data representation, right? Because data representation has become part of our soul, right? So it doesn't actually show out there, but it's got to guide everything we do, right? So that's really the reason why we did that the whole last week. And so today we'll start coding, and I think what we'll do is I don't know if we went over this before. I don't know because I've taught the same material now for several quarters, right? So I don't know if this was talked about this quarter or previous quarter, but here is a very important lesson that we have all learned, okay, over several maybe several quarters of doing CS2A, is to not mess with IDEs until about week 3 or 4, right? Because IDEs tend to be an adventure of themselves, right? As many of you have found, right? Even simple things like even a Visual Studio is supposed to be an easy program to install, right? Because it's been built by people who have encountered the difficulties of installing these IDEs, right? So they said, if you want to start getting going coding, we'll just set you up really quickly, bam, like that, and you're ready to go. But even that, there are a few nuances that people have to. And I think the right time to face these hurdles is not when you're trying to learn programming. Yeah, I think it's the right time to face those hurdles with an IDE is when you're trying to learn a language, not programming, okay? There's a fundamental difference. There's a fundamental difference between learning a language and learning to program. Because, learning to program, you can do it in anything. You can just do it with symbols. You can do it in your mind, okay? Without doing anything at all. You can program in your mind, right? And not using any, syntactical tokens that we find in extant computer languages today, right? Lexical tokens. You may be programming in symbolic logic, in abstract reasoning, right? So that's, so that is learning to program. And you'll be surprised how many people don't know how to program, right? So, I mean, you don't have to, learning to program really is learning to live life in a proper way, right? So learning to reason correctly about things and making optimal choices and so on. And even in programming, you'll find that many people just use libraries or use things that without knowing what it's for, what it gets you, right? Just because there is something called a dictionary, I got to use it for storing some plain array kind of things. You'll encounter these issues, right? You'll encounter these issues, and I think that's why I think it's important to leave the mastering of the IDE to later. Notepad. Mark was playing around with Notepad on day 1, right? And day 1 and probably also day 2. Notepad Plus is pretty cool for most of our initial jobs, but actually we'll do one step better, right? So one step better, actually probably easier too. We'll just use an online environment like Replete or cpp.sh. We'll just go to Google or Bing and just type online C++ compiler. You get like a ton of those, right? You pick the first 4 or 5, you can pick one of those. And I think, and in fact, most of these online environments also give you the ability to store your code, right? Like Git, you can version your code and store your code on that site. That site. And I don't like to do that generally, unless it's code that I don't care about. I just leave it out there so other people can refer to, or you can go back to later in time. But if it's gone, you don't care, right? Because some abc.com somewhere, some random place in the world, and you can't trust that your code you post something there and it's going to be there forever, right? So, but if you treat it like the temporary directory on your computer, right? On your Mac or on your PC, you got a temp directory, right? So stuff that you don't want, but you don't want to delete also, right? You just put it in temp. And so if you, by accident, right, you deleted something really bad, you can always pull it back from there. Yeah, that used to be a habit for me. All right, and then but the temp directory doesn't survive a machine crash, right? So, or if the machine was rebooted, or the sysadmin might say, well, the machine's got too fat, I'm going to clean up the temp directory, right? So it doesn't really belong to you, but you can put it's like a public trash, right? So you put it there and hope that the garbage guy hasn't been around, so that if you really find out that you tossed something really valuable, you can go back and pick it up, right? So yeah, let's leave IDEs alone for now, right? I'm pretty sure by the time we get to week 5, week 6, yeah, and then I think we can, those who volunteer at that time. I don't know. We'll have to do a separate session. We shouldn't use class time for IDEs, right? So I think there's IDE issues, fighting with IDEs and problems with IDEs. I think what we should do is use the STEM center time, because just because of the STEM tutors have had to deal with IDE issues far more frequently than us, yeah, because they have students from other instructors too, right? So it's just me and us, right? But the STEM center tutors have dealt with myriad kinds of IDE problems, right? So, and they might know, well, that happens only if you do it in the Python, thing, and so on. So yeah, make use, right? I mean, they are very, awesome resources at our disposal. We should just basically, and I spoke to a couple of tutors, and they say that it's not being busy. I don't know why, right? Not being busy for computer science, right? So some of the other faculty members, I'm pretty sure, if I went and asked Zach or someone, they, or Patrick, they'd say, yeah, sometimes our math tutors are being kept occupied all the time. But I don't know if that's happening with computer science. But we are paying our tutors, and our tutors are looking forward to helping CS people too, right? So please go, and they know not to give out Quest solutions. Don't bring up your Quest code with your tutors ever. And I say that because it's just going to bite you in the end, right? So maybe a tutor who just wants you off. Well, our tutors are trained not to be annoyed, right? So, but in the past, we've had tutors that were not trained properly and who just wanted to get students off their back, right? And so rather than try and help you find the solution, in which case you won't come back, right? Right, which is actually the optimal thing to do, is to help you find the solution, so you don't keep coming back with newer problems, so you know how to solve them yourself, right? So they just say, I want to get rid of the short-term problem by just giving you the solution rather than teaching you how to find it. So then you go away, right? You got that Quest issue fixed or something fixed, right? So and then but then they haven't really lightened up their course load, because the very next time you encounter something very similar, you're going to go back to the tutor, right? So I keep on bugging them again and again, but that doesn't work. So I think the tutors also learn, right? Through just like us, right? Over a period of time, saying that, giving out the solution doesn't really help, because they keep coming back, right? So you got to show them, or at least, sit them up. I think we spoke about this before, last class. I think many of us find instructors, tutors, professors, everybody, right? Most of the time, it's the students are not coming here to learn, because many of them now already know, right? Even if they think they don't know what is going to be taught, maybe they just need to learn the superficial aspects of symbols and arranging them. But most of them know, and the jobs of these teachers and professors is really to remind the students that, okay, well, this is how you already know this, you make sense of this, right? So this is how you look at it, so that you know it, right? So I think where were you going that yeah, tutors, professors, and yeah. So I think we went over this last class, is that most of the time a teacher's job is not to give you the information or even remind you that you have it, is to make you sit down and not make you leave, right? And put some walls around you and say, you're not leaving this place until you remember that you know it. Okay, it's like the Buddha said, I'm going to sit under the tree, I'm not getting up until I find the truth, or something like that, right? So and 49 days or whatever it is, as legend has it, right? So like tutors, as tutors, I think that's what's going on, really, because given enough time, you'll find the answer, but let alone to your own uncontrolled free spirit at this age. Let's put it that way, right? So got to be a free spirit, but not an uncontrolled free spirit. Doesn't know where to go. It's just diffuse and all over, right? So, and I think what the tutors or the more, slightly more mature people tend to do is basically get this free spirit and box it up a little bit until it knows, right? That, let's learn these other things. And so if you go to the STEM Center, this is one of the greatest benefits you'll find is that you'll find your own creativity, not be, blasted out like a hand grenade, right? So into many places, because you'll find focus. And you'll have people, looking over you, or a tutor might say, do this and, show it to me like 10 minutes, right? And you're going to be sitting there at a table, right? Nobody's going to be watching you, but you've got something to do. And you're going to be doing this and getting back to the tutor. So, but now you are single-minded and focused on fixing that problem and not thinking about the date you're going to have this weekend or, what you're going to have for dinner, right? Or mortgage payments, all kinds of nonsense that creep into your head. But you'll say, well, they all have their place, but I got something to do in the next 10 minutes, right? Which is not the case if you're doing it at home, right? If you're doing the same problem at home, you don't have that sense of urgency, right? So your entire creativity is not focused on it. And so you'll tend to wander and do other things. And then you spend a whole hour. And then at the end of the hour, you will not remember the million things that your mind went and did, right? But you'll remember the one thing that you sat down to do, right? But you never did. You did the million other things, but you never remember the million other things because what you remember was what you sat down to do. And so you say, you blame yourself and you're unkind on yourself, saying, I've spent one whole hour on this problem, but I haven't solved it. But the truth of the matter, if you just sit down calmly and reflect about it, is that you've spent a whole hour, but not thinking about this problem, right? Because you've been thinking about, all these other things, but you just think, record it, have these neural transplants, implants, and record your thoughts. You'll see that, you were thinking about the actual problem for, 1% of the time. Right? But I think what a tutor or a strict parent, no, I don't mean strict in a bad sense, right? Or strict guardian or someone or a teacher or professor, right? Who says you got to do this, right? You don't have a choice, right? Tomorrow night, everything is going to freeze and you don't have a choice after that, right? If you're happy with that, that's good, right? Then right? You know how to put things in. But I think you can save yourself the bitterness of getting to the end and saying, oh, the stress and all the, the sweat building up in your thing by saying that, I'm not going to wait until the last minute because I think that is the only danger I have faced so far, fortunately, with this new way of doing things. Because previously I had, I don't know if you can talk to some of the people who did my classes before I started this, new way of teaching, which is, way giving you more free time, right? Telling you that there are only 2 free states, right? The first free state is for the first 4 homeworks. The next free state is for the rest of the homeworks, right? So previously I used to have micro free states. So I have, the first one due at the end of the first week, the second one due at the end of the second week. Totally did not work for me, right? I don't know if it works for other people. It totally did not work. And people are just focused on just getting past these milestones and they forget, right? So it didn't work. But this way, it's a double-edged sword, right? Because the problem we're having is that people think that we have 4 weeks, right? We have 4 weeks for the first 4 free state. And so let me just wait until week 4, right? And do everything in 1 week because I'm so damn good of a C++ programmer that I need more than half an hour. Don't need more than half an hour to do all of the quests, right? Because most of us think that. And we procrastinate without knowing how deep the problem is that we have to solve. And so that is the other edge of the sword, right? And it bites us. And so I think what helps is to have a decent buffer. Always have a buffer and say, well, I'm going to have a party and have a good time, but I'm not going to front load it. I'm not going to have my party first and then slog for the exam. Let me do my hard work first and get all the quests done, right? And then I have like 2 weeks for freeze date, but I have 2 weeks of nothing to do. Well, not really nothing to do, right? But but I have less work to do for the 2 weeks. I don't have to be stressed, right? So now you can go out and party and have a good time. And I think you'll also enjoy your party more, right? Because without a sword hanging over your head, right? If you partied in the first 2 weeks, you party with a sword hanging over your head. No, that's not a good way to party. So get your work done first, and then you'll be, it'll be fun. It'll be fun. You'll be more free to party, right? Otherwise, you're not free. You're like a prisoner partying, right? Be free and party. Then you don't have to be a prisoner partying, a free person partying, right? So I think that's where we're going. All right, are we all here now? 8:15, which is about the time we actually start talking about real stuff. Okay, all right. Until now, we weren't talking about real stuff. Okay, so well, you know what? Where's Isaiah? I want to make sure that I want to also pull Isaiah because he was also unsure, right? Last class. Is Isaiah here? I can't see him in chat. Hey, Isaiah, are you here? Let me see, because there's a few people I want on class. I want Eddie. Where's Eddie? Eddie, can you raise your hand? Oh, there. All right. Okay, good. So Eddie and I will start programming first. And then I want someone who's not been here before. And I was looking for Isaiah because Isaiah was, unsure of some data representation issues last class. Oh, I don't know. Maybe he's not here. Is he here? Is he here? Isaiah, are you here?
Professor?
Yeah.
Can I ask you a quick question about participation?
Yeah, sure.
So to get full participation points for the week, do you have to post to the Reddit, or if you're like
no, you're doing great. If you're in class, that's fine, right? So if you're in class, participating, this is evidence that you're interested and you're engaged in computer science, right? That's all I'm looking for. That's even if there have been people in the past, and you go look at some of the past Reddit posts, you make the post, but you can tell immediately that the post was made for participation, right? For the purpose of showing that, I'm around. Intelligent people can look at these posts and figure it out, right? It's not like I'm going to penalize people for doing that, no. But but this counts more to me. Like someone who's actually in class, or even in Reddit, right? Someone actually making a meaningful post that is actually useful, right? Even if it's something that's been talked about already and posted 100 times, right? Still posting something, a new perspective, something interesting, enjoyable, right? Those are the kinds of things that I'm looking for. And so it doesn't matter, right? And so you guys who are attending lectures, right? I think that's fine. Attending lectures, being, part of class, even if you're upside down like Isaiah for now, right? Hey, Isaiah, you got to turn your camera around, man. All right, no, not sideways. All right, okay, all right, okay. All right, he's playing around. Okay, I'm glad you're back because, you were the second guy I was going to pick on. So I'm going to code with Eddie first, okay? I'm going to program with Eddie. And then maybe Isaiah, and then I'm going to pick up some 4 or 5 people, right? So all of you guys hang around, and then we'll do one at a time. And basically what I want to do at the end of this class, before I take off, right? Before I hand over the stage to you guys, okay? Before I take off, and you guys should be doing the same thing. I think it'll be fun, right? We'll just start up an environment, and it's going to be an online environment, okay? We'll just use cpp.sh, repeat, or something like that. Start with the browser, which means you don't have to do anything at all. You come on screen, okay, on stage, and together, we share your screen, okay? Hey, Eddie, you got a screen that you can share, right?
Yeah, I got
okay, all right, great. And the rest of you also make sure you get a screen. If you don't have a screen, just let me know so we can share my screen instead, okay? But whoever is on stage, the 2 of us are going to be performing, okay? Not you on your own, 2 of us, okay? So don't worry. Okay, either 2 of us, or you and Mark, or you and Elizabeth. You are saying two people at a time, right? And yeah, sorry.
I was going to ask a question. So for the first quest, I think one of the results was measured in Slickerberry Snoozlestone's mine, and I'm just curious, is that a function of
it doesn't
time?
matter what it is, okay? Just what it shows on the /Q site, the total number of trophies is what matters. Have you been to the /Q site? Yeah, the /Q site tells you how many trophies you've got altogether.
Oh, I should check that out. But I was just wondering, is that a function of time primarily?
No, it's a function. Oh, you mean the number of rewards you get?
Yeah.
So any quest, not just the first one, any quest, the total number of rewards is how closely you match the reference output.
Oh, okay. Thank you very much.
All right, great. So that's what we're going to do, right? 2 people, and we're going to code. And then at the end of the session of 5 minutes or 10 minutes that I spend with one person or the 2 people, right? That's it, gone, right? Everything is deleted. Not deleted, but that's it. Not available for the next pair, right? So, and then maybe let's pick a couple of people, right? So I got Eddie and Isaiah. How about Andrew Razzo? Andrew, well, because you're not even on screen, right? So if your camera is switched off, I'm especially going to call you out. All right, okay, Andrew, are you there on class or not? Andrew? Okay, all right, see, Andrew, you're not here. You got to be present in class, otherwise this doesn't count as participation, right? You can't just switch on your, log into Zoom and switch on off your camera and microphone and take off, okay? What about this other Eddie, laptop Eddie? Hey, Eddie, is your last name really laptop?
No, that's what I'm gonna be using for like just showing my screen as well.
Oh, I
these
see. It is
days.
the same Eddie.
Yeah.
It's the same
Yeah,
Eddie.
it's
Oh,
same.
yeah, yeah. Okay, all right. I thought it was a different Eddie. No, no, don't worry. Okay, good, good, good. All right. It's like on an iPad, right? So I got my last name is an iPad. Okay, but you do see the iPad, right? So I usually have it up there in case Peter comes by. All right. Who else? Who else? Who else? Okay, Srikaran, you haven't been on screen and you've been very, very quiet so far. Okay, you want to be number 3 today?
Okay.
Okay, all right. So we got 3 people. Okay, so after we finish the 3, more people can, come on screen. Maybe David or someone else. Or Jacqueline. This is Jacqueline. It's the first time I'm seeing you in class. Were you in class before? Did you just get an ad code and join us?
I was in class. I just had my video off, so.
Oh, I see. Okay. Well, anyway, well, welcome to class. Great. Which means I don't have to tell you to watch the videos that, I think we recorded and they're all public and posted. Okay. All right. Jacqueline, Charlie, Ure. How do you pronounce your name? Ure?
I go by Ray.
Ray? Ray.
Yeah.
Yeah. Okay. Ray. All right. So you guys think about it. Okay. Think about coming on screen next. Okay. All right. Eddie. So let's take the screen and open up a browser on your laptop, computer. Okay, just open up a browser and share that browser screen. Okay, and follow on. And then the next person to come on, who's going next? Is it Isaiah or what was the third person's? Who did we pick? Was it not Andrew? Obviously.
I don't know what we're doing. I just logged in.
No, you don't have to know. You should not know what you're going to do. All right, so we're going to do it together.
Wait, what?
Yeah, you should not know what to do. So hang on just a sec. I want to pick the third person. It was Eddie and Isaiah, and who was the third person? I keep forgetting. Who's coming on screen third?
It was me.
Srikaran. Okay, all right, good. All right, so Isaiah, just watch what we're going to do with what Eddie and I are going to do. That's what you and I are going to do next. Okay, and so if you have any questions, just save them for later because
Professor, I have a question.
Who is it?
It's me.
Jinghang.
So what are we required to have on our computer, like a software or something else to for us to type our codings?
Yeah, we'll talk about that today. So that's what we're going to do today, right? So this is how we're going to start off coding. Yeah, this is how we'll start off coding. And in a couple of lectures, we'll see how we don't code online in a browser. We'll just code on your local machine. That's where you're going. Yes, so we'll cover all that. Don't worry about that. Jinghang, is that okay?
Yeah.
All right, Eddie, share your screen. Open up a browser.
All right, this is what I got.
Okay, great. All right, hey, Isaiah and the rest of you guys, are you following? You just have got an open browser here, okay? Type in online C++ compilers. All right, it's exactly what we're doing, right? Online C++ compilers. All right, what we're saying here is I want to compile my program, but I don't want to install this, Visual Studio and all these things, I said, I just want to write a program and see if it runs or not, okay? So tell me if there's something that'll just do it online inside of my browser. That's what we're saying. Okay, so what is it? We have a bunch of these here. I've never used online GDB. I've used tutorials point. Let's just go to cpp.sh, okay? So you see the one at the bottom? Well, that's the one we've used a lot of times, right? So yeah, click that. Yeah. So what this gives us is a place where you can type in your C++ program. Okay. And in fact, you'll see that, when you go there, you automatically even get a free C++ program already there, right? It's already there. So that is a program. If you just run this program, click the run button. Okay. Hey, Isaiah, Srikaran, all of you guys following? Okay. Click the run button there. Hey, Eddie, click the run button.
Yeah. Give me 1 second. Sorry.
Yeah. No worries. You see the funny thing, I leave him the apples, but he always goes for the nuts before he eats the fruits. So obviously that's what he likes, or not a fruit person. Well, hey, are you ready? I'm just waiting for you, Eddie. When you're ready.
Oh yeah, no, I got it. I got it
Okay,
going.
call. Yeah. So sometimes when I'm just doing something else, I'm just waiting for you guys. Or I'm distracted. You got to pull me in. Okay. So there you go. So it's running. So just get rid of everything inside of the. Go back to your program and click stop. Click stop. Click stop. Click stop now. Right. Get rid of everything inside between the braces. That is your program. Essentially, that is your program. Okay. This is your template. This is the very first template you get. Anybody will. That's a template. Now in your program, just say return 0. Return 0. Okay, return. No, it's not rerun. It's a return. RETURN. Yeah. Yeah, it won't get picked up by a spell corrector, right? So, all right, return 0 and then semicolon. Everything in C++, you got to end with a semicolon. Every statement, right? End with a semicolon. So, all right. So that is your minimal program. In fact, in order to do that, you don't even need at the very top of the program, you see those 3 lines, right? Hash include IO stream, hash include string. You can even get rid of those lines. Get rid of those lines too, right?
These lines, right? That's what,
yeah, all of them. Get rid of all of the lines. Yeah, exactly. Yeah, everything. All right. Okay. So that is your basic minimal C++ program. Okay. It does absolutely nothing. It just tells the operating system I ran and I died with no error. Okay. That's what return 0 means. Okay. So return any C++ function, as you guys are probably reading the first Quest spec, right? It hello world and the tiger called Fangs or named Fangs or whatever it is, right? So you see that every C++ program is basically composed of lots of functions, right? Functions, one function calls another, that function might call 10 other functions or another function many times and so on and so forth. But everything is basically a function call. A function call is simply a set of instructions. All right, a set of instructions that tells a CPU inside of my computer. This is my computer. There's a CPU inside of my computer, which basically needs to get given a set of instructions. Right. Anytime anything I say is confusing or you need me to go slow or any question, right? You got to stop and ask. You can't just say okay, right? Like Isaiah said last time. That's why I was, I picked that up, right? So you can't say okay even to yourself, right? But many times we just say okay even to ourselves. And just move on, right? So that is our loss. It's our loss, right? No, if you don't understand it, you ask why, right? Try and figure it out. It has to make sense. If it doesn't make sense, you're not living your full life, really, right? So try and make sense of everything. And where the hell were we going with that? Okay, so
Professor.
Sorry.
I had a question.
Yeah,
so
sure.
What would happen if we didn't have that return 0 statement?
Yeah. So, all right. So here, what we're saying is that, yeah, thank you, Chris. Okay. So we have a bunch of functions, right? So a function and the CPU is inside the CPU in your computer. It's waiting to run. Okay. And then it is a bunch of instructions only the CPU can understand. Obviously, this program is written not in CPU language. It's written in something like English, right? It's got a word called main. Okay, and it's got another, kind of pseudo word, a half-ass word called int, right? Int is basically a half-ass word. It's some kind of crazy abbreviation that we decided to use, saying int. Well, I don't want to type the whole word integer, right? Which is a dictionary word. You find it in a dictionary, English word integer, right? Integer means it's a whole number, right? And it can be positive or negative or 0. Right? So I don't want to type integer every time. I just say int, right? Because I'm going to be using so many ints in my program. I want a short form for saying int, right? So all these abbreviations we introduce into the language, right? Because, you go to talk to a doctor or a lawyer, they have their own abbreviations, right? And why do they have abbreviations? They have abbreviations because there are certain terms that you'll encounter in that field many, many, many times, right? So because you encounter that, because people outside of the field, they don't need those abbreviations, right? They can afford to say, let's say, take a kaleidoscopy or something like that. Some complex word, right? That only doctors maybe know. All right. So and then they basically talk to each other and say, hey, did you do a CCP on that patient? Right? Oh yeah, that CCP was a failure. Oh, that CCP has a 96. So they talk about CCPs. Right? We have no idea. They have abbreviations, right? But you only know that as a doctor, right? Outside, for us, this is a kaleidoscopy or something like that. So we have to use the whole thing because we like that. Outside, non-programmers need to, even when you're not a programmer, you say integer, right? So, but when you're going to be using so many of those, you say int, right? So we created extra words and stuck them into English, right? And not even words. We even stuck in symbols like, braces, right? Curly braces, not really part of English, right? We introduced them into this language, which is like English, but, a simplified version of English, so that we can understand. But this is not something a CPU can understand, right? This program is not something a CPU can understand. So a program will need to be, that program needs to be translated from whatever language it is, which is not the CPU's language, right? It may even be in machine code that is in a different machine's code, right? Maybe it's an ARM program, right? ARM written for ARM CPUs, but this is a Intel CPU, right? Still needs to be translated. Doesn't matter. If this CPU only understands the language that this CPU was built for, right? So that program is in C++. So that needs to be translated, right, from that pseudo English kind of freaky looking syntax, right? It needs to be translated into ones and zeros. Okay, and I'll show you, right? I'll show you. So how is that thing? That process is called compilation, right? So compilation is a process of taking, an English-looking program, or at least a program that you can look at without hurting your eyes. Okay, right? So that kind of program. So taking that program and turning it into something that only this CPU can understand. That is called compilation. But once you turn it into something that only this CPU can understand, that translation process is also the strength as well as the weakness, because it's so strong now because it doesn't need to be translating back and forth every time. It's already translated to the language the CPU can understand, so it can just zip through it, right? The disadvantage, the double-edged sword, right? So disadvantage is that now, even though it is like blindingly fast, it is blindingly fast only on this CPU, right? If I want to take the same compiled program and run it on an ARM CPU, now again, it's going to be slow because it's going to be translated from Intel to ARM. Does it all make sense? Right? So that is the translation. There's a compilation. Now we'll go back and talk to Chris's question, right? I'm sorry, Chris, that it takes so long to get to answer your question, right? So Chris says, right, so here's this program. What happens if this program doesn't return anything? If you had open and closing braces. Now, always I say, and this is something that didn't used to be the case, like 20 years ago, 30 years ago, right? Before I learned to program, right? Is that compilation and testing things used to be so costly, painful, time consuming, lots of effort, that people didn't have the luxury that you guys have of basically just, if you want to know what happens, just try it out. Right? It doesn't cost you anything, right? And it's really fast. You're not going to break anything. Even if you break something, you want to break that computer that is somewhere in the cloud, someone's computer out there, right? Not your no, it shouldn't be. That's not the attitude to look at it, because there's a million things you can do right now to basically crash that system, right? If you're a C++ programmer, unless it's running in a container that's they've got the protections in there, but if most self-taught programmers who haven't taken the right precautions, right, they might be running a C program right in their web server, right? And you can basically screw up everything if you hack into it, because they're using the power of C, right? So if it's not properly run in a sandbox, you can make operating system calls and basically totally screw up the machine. So I don't know where we're going with that, but yeah. So this C++ program, yeah, we can test it. We can keep testing anything, right? So we're going to test what Chris said, but before we test it, let's run it in our head and think about this and see what is going to happen, right? And then we test it and say, well, what happened was actually what we thought should happen. So that's kind of cool, because if what happened was not what we thought will happen, then our scientist gene will kick in and say, hey, that's really interesting and juicy. That's a new puzzle for the day, okay? So this is what we think or thought should have happened, but that is what actually happened. Why is this discrepancy? Right? Why is it? And so that's the kind of discrepancy that's really the bread and butter of all scientists, whether you're a computer scientist or a physics expert. It doesn't matter. Doesn't matter what science you're pursuing, or what reasoning thing, right? So being human, if you see a discrepancy between what you expect and reality, you're naturally going to start wondering, and that could keep you occupied forever, for ages. No, not forever, for ages, right? So here, what we're going to try and do is basically try and construct a mental picture of what is going to be, given the background that I've given so far about the program converted to and the CPU is running those things, right? So now we'll look at what the compiler expects from the other side. So it says, well, the compiler, the C++ compiler here, click on the compilation tab. Hey, Eddie, yeah, click on it. It doesn't say much. Open another tab, and go to Replete, right? Go to Replete. I think I want to just go to Replete, repl.it, right? I want to go to some place where you can get a shell so I can show you, right? So Replete. I think they give you oh, you got to log in. Oh, start coding. Yeah, start coding. Click start coding. Damn. Okay. All right. Okay. Let's go back to that other one. Don't worry. Okay. So I didn't realize that you have to log in and create an account and so on and so forth. Okay. All right. So anyway, what I wanted to show you was, logging into that machine and then looking at your source code as the machine would look at it, right? And then compile it and then look at the ones and zeros also, right? And say, well, this English looking thing in CPP is what you can see as humans. This other program, hello world, or XYZ is in ones and zeros. And although it's exactly the same thing, they mean the same thing. This is not written in a language that you can understand, but this is written in a language that the CPU can understand. I can actually show you that. It's actually really cool. Maybe later on, I'll share my screen and I can show you that. Or someone can figure out how to get into Replete, and the next person, maybe Isaiah or someone else, right? When they get into Replete, we can show, right? As that. Okay, now let's try this. Yeah, what we need to do is, so the compiler says, here is a syntax I'm looking, right? So suppose you went to an English speaker, right? Suppose you went to an English speaker, they don't know any other language, and you spoke to them in completely broken, incorrect English, right? Incorrect English. No, let's take a very, I want to go to the, I want to catch the bus, right? I want to catch the bus. And suppose you tell them, so you tell them the same thing, but bus, and you omit some keywords, right? Just say something in some highly ungrammatical thing, right, to them in a way that doesn't make sense. Many times you have second language speakers or foreigners come and talk to you. You can actually make out, right? They might use the word catch, bus, and so on, and then you can make out with gestures and so on, right? So assume you don't have any of that luxury, okay? But they're talking to you in English, and they think they're talking in English, but it's not proper English. You can't understand them, right? So you'll say, no, I can't. I'm sorry, I can't translate you. That's exactly what the compiler will say. The compiler understands a certain subset of English, let's say embellished in a certain way that lets certain things be easier, like saying int instead of integer and so on and so forth, right? So the compiler understands that language only. And so it tells you that if you speak in that language, I can translate what you say into ones and zeros for the CPU. If you say anything else, I cannot translate you. So which means when it says I cannot translate you to the CPU, it's basically going to say, red ink there, red ink there. And there are lots of newbies who get confused and scared away by the red ink, right? So yeah, let's not get scared away by all of that today. And so here, what we're telling the compiler is that, well, when my program starts executing, right? My C++ program has got a lot of functions in it, lots of functions, okay? So when my program starts executing, which function are you going to call first? Because you got to call one function, that function can call lots of other functions, right? But to get everything started, what is the first function that's going to be called, right? So in C++, Java, many other languages, right? We make a conventional decision and say there is going to be a special function, right? Called main, okay? Main, okay? Special function called main. You are not allowed, nobody's allowed to use the word main as the name of a function of their own, right? So it's a very useful convention, right? So so main is a special function. The compiler knows. Every compiler that if you write a compiler, you're going to be looking for a function called main, right? Later on in your life, right? So the compiler will look for a function called main and tell the operating system when eventually the user wants to run the program, here is a function that you should call, okay? Because if you don't tell the operating system where main is, when your program is run, the operating system doesn't know what to call. Yes? So your program is basically a whole bunch of function calls, but the very first function to be called by someone else, basically by me, through the operating system, is main. That is an understanding that we have to have in place. Okay? If that understanding is not in place, nothing will work. So let's just start with that. So is everybody okay with that understanding? So main is a special function, right? That is where everything starts. Okay. Now, Chris's question was that what if main didn't return anything? Okay, so now if main didn't, so what does main return, right? Every time you call a function does something and then returns a value to us and say, well, I did that and this is the result, right? Or it may say, I did that, that's it, right? No result. That's also possible. These are called procedures, or historically called procedures. Let's just call them void functions these days, right? Void functions is a function that does something but doesn't return anything to you, right? On the other hand, a function could do something and then return something to you. Like, for example, I can write a function that is going to ask someone, what is your name, right? And get the name and then return to me a string. Yes, Chris? Yeah, so that function is a function that returns a string to me. Another function basically says, when you fire me up, when you call me, all I'm going to do is just paint the wall red. Okay, that's it, right? And it's not going to return anything to me. Right? Yeah, I don't know if it's a good decision, but maybe that's possible, right? So maybe because if it returns something to you and you don't know what to do if it failed, might as well not return anything, right? So I think Ken Thompson, who was one of the inventors of C++, and not C++, C, or Unix, the operating system Unix, he made a nice observation about programmers. I don't know, right? I might as well say it now before it becomes extinct, right? Because fewer people seem to know it. I think it is that don't test for an error condition that you can't handle, okay? It's like Jack Nicholson says in that movie, right? Hey, you want the truth, you can't handle the truth, right? Like that. If you have a function and that's going to fail, right? But you don't know. If you don't know, you know what to do if it succeeds, but you don't know what to do if it fails. Don't do an if statement saying, oh, if it succeeds, do this. What are you going to do if it fails? You're basically screwed at that point, right? So you don't test for an error condition you don't know how to handle. Okay, so it's a very nice statement, isn't it? So you know, computer science, the field of computer science, I think it's a field of anything, right? Any field, right? It's just filled. The field, it's littered with little gold nuggets like this, right? You know, every time you walk around and you just find, right? There's so many geniuses in every field, and you just walk in their footsteps, or walk around where they went, right? You just find these little nuggets, and the important thing is to just cherish them, right? And enjoy them, right? Add a color to your own life, like it added to their own life, right? To their life, and so. So, where are we going there, right? So yeah, it's int doesn't return anything, right? So yeah. So when we do something and we return a value, so we return a value to us when you call a function. Now, main is a special function. Main, you're not calling main. Talk to any C programmer, right? Except for the guys who write obfuscated code and things like that. I don't think there's any C++ programmer there that calls main, okay? Calls their own function or main. The operating system is what calls main. So what sense does it make to return a value in main, right? Any other function you can return a value because you're going to be receiving the value and do something with it, right? But what happens if main is going to call you, right? So what happens to the value you return? Who gets the value? The operating system gets the value, right? So, but what does the operating system do with the value, right? So the operating system also, if you think about it, is not the do all and end all. It is just a mediator. Who ran the program? The operating system didn't run the program. Who ran the program? You ran the program, right? You logged into the command line and you typed the name of the program and hit enter, or you double click the icon, you ran the program. So whatever the program returned is not for the operating system. The operating system is just a relay, someone in a middleman, right? So the only business the operating system has is to accept what the program gave it and give it to you. Whether it is something to the console, which it presents on a console for you to read, or whether it's an exit status saying that the function was supposed to return an integer, right? And it returned this integer and gives it to you. How does it give it to you? It sets what is called the exit status. So there is a way in which if you invoke a program in C++, you can test the value that is returned by main. Okay, and programmers use it all the time. So let's not worry about it now. You will use it later on in your own scripts when you write programs that call your programs to do things, and then you want to test if your program succeeded or not. But you're not a C++ programmer. You're a script, right? You're a script that is calling a C++ program. And that program is running and returning something to the operating system. And the operating system set a status saying failed or succeeded, right? And you're a script and you need to decide what to do next. So you'll see what the operating system return, right? 1 or 0 or 2 or 3, and decide what to do next, right? So that is where the return from main actually matters. This is a very long-winded answer to Chris's simple question. So we're going to try and return nothing from main. So let's get rid of the return 0 completely, right? Get rid of that statement, right? Obviously, Isaiah and all these other people who are going after this, we're not going to be talking as much when we're coding with you, right? With Eddie, we're taking it slow because I'm talking about a lot of fluff along the way. But as we progress, we'll have less fluff and talk more about it, right? So don't have to worry. Okay, so main, now try and compile this. Try and run it. Will it say no? And you have to click on the execution tab, I think. Yeah, it would actually automatically switch, right? So as it turns out that it actually worked. Okay, it ran. Now get rid of the int in front of the main, because strictly speaking, it is I think now the compiler will complain, right, and say this is not right grammar. When a function needs to have a type, return type. Okay, so run it. No.
Yeah, it's going, or I mean, it's not running because it.
Oh, but it's giving you a warning.
Yeah.
Oh yeah, mouse over. Yeah, okay, now it's only giving you a warning. Okay, so meaning that what's going on here is that if main does not return a value, the compiler is automatically filling in one for you. Right? It's giving you a freebie. Now you can test it out by defining another function, right? Go on top of main to the first line and define some random function. Say function returns integer, int space, say Eddie's function, or Eddie's underscore function, right? And then it takes no parameters at all. So open close parentheses, open close parentheses, and then space, and then curly brace, space, curly brace. Yeah, and then enter a couple of times, actually put some space between, the main is too close. And also there's a space before the main. I put a blank line before main, put a blank line before main, and then get rid of the space so that it's all also, also looks clean and nice, right? No, get rid of the space, and then put a blank line before that so that main by itself is a chunk, right? Yeah, there you go. Okay, so Eddie's function is right at the top. So we're creating a brand new function which is supposed to return an integer, but it's not returning anything, right? Now in main, call Eddie's function. The way you call another function is just by naming the function and putting the parentheses after that. So in your main, just call Eddie's function, right? Eddie underscore function. Space, and when you call, every time you enter the curly brace, you belong to the curly brace. And the way conventionally we signify belong, all of you guys who are going to come coding after Eddie, I hope you're paying attention and listening, okay? Srikaran, Isaiah, I don't see Isaiah, okay? So all of you guys, right? So these are stylistic issues. Doesn't matter to the compiler, doesn't matter to humans, right? Yeah, sorry, Mark?
Isaiah's there. He's on camera. We can see him.
Oh, you can see him?
Yeah.
Oh, why can't I see him? Maybe my gallery is only showing 4 people. Hang on. Oh, okay, yeah. I just need to make the maybe I should use 2 screens. No, this is okay. No, I can shorten. I can small size the terminal and then put my double glasses on. All right. So these are my magnification glasses. So oh yeah, cool. All right. So I can see all of you guys now. All of you guys, and the font is big enough for me to. Hey, some of you are smiling. I didn't even know that. That is so cool. Okay. All right. No, I'm just kidding. Okay. So Eddie function. All right. So the way you call a function from another function is just name the function. So and then stylistically, right? So no, indent in. When I say indent in, what I mean is basically make sure the way we indicate to another programmer, to ourselves, that we belong to the set of curly braces or belong to the function that owns these curly braces is by moving inside 4 spaces, right? And don't use tab, right? Use 4 spaces. Okay, now you say Eddie underscore function, right? And then open close. Yeah, and then semicolon. Right, that means, and usually what I do, and you don't have to follow this, I usually don't have a space between before the opening parentheses, right? Because then the parentheses looks like it belongs to that function, right? So it's part of the function call itself, not a separate entity byte, right? So okay, so Eddie underscore function is being called from main. Now try and compile it. You still have the warning because main is still not returning anything, but it is. There you go. Okay. All right. So it is refusing. Is it it's warning again? It's only warning. Okay. So I don't like that. I wonder if it's this case with Xcode and other environments too. Maybe this is just some version of G++ that is not. What are the options for compilation? Click on options. Click on options. Well. Yeah, okay, well, I don't know. I mean, we can always click extra and pedantic, but that's not the default you guys are going to get, right? So let's not do that. Right, let's go back to compilation. I think Chang Yi had a question.
Yeah, mine is working. Maybe try the first flower parenthesis to another line.
No, it'll still work.
Because
it doesn't matter, right? Yeah, it'll work. It's working.
Okay.
It's working, right? But it shouldn't work. I'm saying it shouldn't work because we're telling the compiler that Eddie function is a function that's going to return an integer, but we're not returning an integer, right? And the compiler is automatically filling in a 0 or something for us there. It's automatically returning something for us when we're not explicitly returning, right? The right way to declare Eddie's function is to turn the int into a void, right? Turn the int into a void, right? Yeah, that one. So void, then your warning will go, the first warning will go away because now you're saying Eddie function is a function that does not return anything, right? It doesn't have to do anything right now, but it doesn't return anything, right? It doesn't return. Now, if you compile it, you'll see the first triangle go away, right? Because now we've told the compiler that array function is a function that is a void function, doesn't return an integer, right? And like we said, it's not returning anything, right? So the compiler doesn't warn us, right? Doesn't complain. No yellow triangle there. Does it make sense, Eddie?
Yeah, that makes sense.
Okay, all right. So no, strictly speaking, main also should not be doing this, right? And in fact, this is a bad signature. Yeah, it's not. Maybe it's. Yeah, I think it's just inheritance from C, right? So C++. One of the, despite the great power and beauty of C++, some of the, and I think it's also one of the nice things I like. I think is not even a drawback. It's like, so C++ is also tolerant of C, meaning it's tolerant of its predecessors, right? Stuff that's gone before it and has laid the groundwork. It doesn't, without humility, right, dismiss it and saying, C is all crap. I'm going to get rid of it. I'm not going to use anything even vaguely resembling C. If it resembles C, I'm going to. No, it says, C has done a great thing. We're going to build on top of that, right? So, which means that if there's something that is kind of not C++, but it's not like deadly wrong in C++, it's wrong in C++, but it is required for C, I will still support it. So that is the attitude that C++ has brought to this entire, ecosystem of programming languages, is that, that is actually a valid declaration in C, right? A historical language in C, that's a valid declaration. It's the main function. That's my entry point. All I, in C, which, one of the first languages, right? After assembler is all the compiler needed, because the compiler in those days was really, really simple, right? I give the compiler, the first compilers that were written for C, we can write it as part of our CS2C project. No, maybe not CS2C. Maybe you can write it in your first year after you transfer, right? You don't even have to wait until your senior year at 4-year college, right? So the early compilers were so simple that you can just say main and it'll let that slide. And so all it said was, just tell us what the entry point is. And so even though main was supposed to return a value, it didn't enforce that. And that's the reason. Let's put back the signature as C++ requires it. Main should always return an integer to the operating system. So before the word main, also say it's going to return an integer to the operating system, right? Say int. Right, and then at the end of main, before the final program, before the curly, right there. Thank you. Just say return 0. Return 0. No, you have to. Everything that is part of main has got to be indented in. Yeah. Okay. Now return 0 and then semicolon. Every statement has to end with a semicolon. Right. Semicolon. Right. Now, if you compile and run it, it'll say program ran and it returned an exit status of 0. You see that exit code 0 right at the bottom? Right, that is what the operating system got. Now change the return 0 into a return, I don't know, 115 or something like that. Some number less than 255. I think it has to be even though it's int, I think it needs to be. Actually, let's try this, right? Because we just got to try these things. Give a number bigger than 8 bits, right? 8 bits is 256, right? Give it a number bigger. Give it a number like 10,000, right? Return 10,000. Yeah, 10,000. Right, 10,000. Yeah, whatever. Some big ass number, right? So yeah. All right, now enter and run it. Let's say, see, I think it still needs. So if you return the exit code 256, I'm pretty sure it's going to return 0. Return the exit code 256 because 256 is basically 1 in and then all zeros, right? It's 2 bytes, and so 256 returns 0. See, exit 0, right? 256 is it's so I want so even though it says I accept a return value of an integer, it is not looking at the whole integer. An integer in C++ is composed of 16 bits, right? Originally, you remember in data representation how we said 8 bits for a character and 256 possible values, right? And in signed and positive signed notation, you have negative 127 to negative 128 to positive 127. 256 possible values in data representation. Yes. Okay, that's one character. But but integers are bigger than characters. People said, integers, characters are not big enough to count all these things. I want integers. I want to go all the way up to 65K, right? So they use 2 bytes. 2 bytes is 16 bits. So an integer is 2. And in fact, today's integers are not even 16 bits. In fact, let's do a couple things here. Eddie, the things we're going to do now to this program are essentially going to help you complete the first few quests. Okay, so go right to the top. In fact, before you go to the top, in eddy function. So let's not do anything in main, okay? In main is just going to call eddy function, and let's do everything in eddy function. All right. So inside of eddy function, go into your eddy function, and so return 0 instead of return 0 instead of return 56, right? Return 0. Right, which means no error. If you return 1, it's going to say exit status 1, so you'll know, right? So all right, so in eddy function, let's say we're going to output a value. That's all, right? We're just going to output a value. Let's say output. See out. I'm going to say, right? So we're going to try all this out. I'm going to get red ink and going to fix these things, right? See out, and then this is called the left shift operator. 2 less than signs, 1 next to each other. That is called left shift. Now, those of you who read module 0, data representation, you know that's a bit pattern. You can shift the entire bit pattern to the left or right, right? It's the same as multiplying by 2 and dividing by 2, right? So shifting to the left is basically left. That is a C++ operator to shift something to the left, right? Likewise, you can shift everything to the right by 2 bits, right? Now, those 2 operators also have another meaning. They have been overloaded. They have another meaning in C++. This is also called using the left shift operator. So I'm going to call it the left shift operator. So some people call it the insertion operator, right? So that is an operator. See out, left shift, and just say, hello, this is Eddie, within quotes. Make it a string, right? Hello, this is Eddie. This is Eddie. You got to make it grammatical too, right? You got to not just C++ syntax, English syntax also, right?
Yeah, I'm sorry. I've been up for like maybe 40-ish hours.
I know.
I apologize.
I'm really grateful that you're doing this much at least, right? So I'm thank you so much for that, right? And I hope this is not too tiring or something. You let me know, right? Because we can put Isaiah on the hook and let you go. All right. Now,
it's life.
Right now, there is something, if you run that, well, let's run that, and we're going to embellish that bit by bit, okay? So if you run that, it's not going to compile. It is going to say, I don't know what you mean by C out, right? It says, I don't know what C out is. Yes. Do you see that? And yeah, there you go. It says that. Yeah, there you go. You got a red triangle too, right? No, not red cross, X, right? Yeah. Red times. That means an error, right? In Xcode, on VS Code, it's not just going to be the axis. You got a red on the margin. It's going to be underlining with red. You're going to be, it's like going to be a professor with red ink, right? And first time using a red pen all over the place, bang. It's really nice, right? So in Xcode, but here in I think it just gives you, so that's an error. That means that that line, the compiler can understand, it cannot understand that line. So it doesn't know what cout is, but it knows what a string is. That much has been built into a compiler. The compiler knows if you have something between 2 double quotes, I should treat that as a string. That it knows already, right? But it doesn't know what cout is. Now, cout is an object that has already been created for us, right? We don't have to mess around with creating some objects that have already been created. So what C++ designers did, right? So all of you, someone needs to time mark this and maybe make point in the YouTube comments, is when we start using C++, it's really hard. So it's called the bootstrapping process, right? How do I know? How can I program on a compiler on a computer without actually seeing the output or typing things in? So there needs to be some way for a human to interact with the compiler, right? So now, strictly speaking, the CPU program doesn't know anything about interacting with humans, right? It just knows how to do this stuff. So in order for that to interact with humans, you need the bare bones operating system, and you also need to build some stuff on top of that that knows to interact with humans as well as, so you need that middle layer. So someone has to build that middle layer that can talk to the lower level hardware, right, through the CPU, and tell the CPU to talk to the screen and the keyboard and so on and so forth, right? So that some object needs to exist. That needs to be built first, right? That object needs to be built. That object will then talk to the human and then convey the human's intentions to the CPU. That object needs to be built. Now, if you're starting out with programming, the first thing you're going to do is going to have to build this object, right? Because before you build that object, you can't talk to the CPU. So if that is the case, nobody, I can assure you, except for 1 or 2 people like von Neumann, right? Nobody's going to be programming. Right? Everybody's going to say, I love to program, but I'm not going to go and type these. I'm not going to go and create the cout. I'm not going to create these device drivers. And I'm not going to create these shells, right? I don't want to be the person that's going to be responsible for doing the grunt work of talking to all these machines. That is routine, right? Everybody knows how this has been published like 1 million times in literature. Someone go and write this, device driver to talk to the screen. right? So because that is also standard stuff, and that is so essential for someone who wants to talk to the CPU, the C++ designers have taken it upon themselves, right? Many decades ago, when the compiler was created, they said, as a programmer who wants to use C++, right, go ahead and already start using these basic building blocks, these Lego pieces that I've already built for you, and you build stuff on top of these. So they have gone ahead and created the very first C++ things for you already using C++. So cout is an object in C++, right? Just like any other object you're going to create later on, cout is just another object, but they have created it themselves and given to you as a package, right? So when you start programming in C++, right, don't start programming like we did, right? Starting with absolutely nothing, a blank slate. I'm just going to start with main and 2 braces, right? So let's say I'm going to start programming, but I'm going to start programming with the giants who have come before me, helping me. And the way you do that is go right to the top of the program and say hash include, right? And then angle brackets, I think less than, right? And then inside of the angle brackets, you're going to say IO stream, right? IO stream. Now, IO stream is a library that has already been written for us, because if that hadn't been written, the first 5 months of our C++ adventure is going to be around writing IO stream before we do everything else, right? Because every programmer is going to have to do that. C++ has already done that for us, right? So IO stream has been written, it's out there. IO stream already has definitions of 3 important things that we're going to use, right? It defines the cout object. The cout object stands for console output, cout, right? So anything you send to cout, the operating system knows through this library to send to the console, which is your screen. If you send stuff to cout, it's going to hit your screen. Yeah. Likewise, it also makes available to you another object called cin, which is the console input. How do you talk to the compiler, right? There's a keyboard, right? So the console input, which is cin, that has also been created, is ready out there. Anytime you start programming, cout and cin are given to you for free. Right? So with cout, you can talk to the compiler, to the user through the screen. With cin, you can read what they type. Yes or no? All of you, not Eddie, right? Anybody else, right? Do you have any questions so far?
Got you. So far, no. Everything up to this point is making sense.
Great. Okay. Now let's compile and run it.
I had a question, Professor.
Yes, go for it.
Would we do the same hashtag include for any all libraries?
Yes, any library
Okay.
that you use, right? Later on we'll encounter, right? So like, for example, I think when you get to week number 6, we'll be using something called a vector, right? The vector is basically an array of objects. So then we'll hash include vector, saying, oh, I want to use a vector. I want to use all the nice things that people have already programmed for me using a vector.
Do you need a semicolon after the string?
Hey, why isn't it running? Yeah. I think you need a semicolon. Why wasn't it compiling?
It's still not compiling.
What?
I think you need the STD.
Oh yeah. I'm sorry. Yeah. So what the IO stream, what it did was it created this object called cout and cin and things like that, right? What does it mean, right? If I'm going to, it means it's a global object, right? So anybody, this global meaning, it's cout is available to anyone out there. It's a global object. If that program has like 1 million functions, all those functions have access to cout. It's global, and so that means that if some programmer wants to create an object themselves and have the same name, so they want to create an object called cout, right? So how can you do it? Now there's a conflict, right? Now when you say send something to cout, the compiler doesn't know whether to send it to your cout or to the operating system cout, or to the standard cout out there that's already been given to us, right? So anticipating that kind of name conflict problem, C++ introduced what is called namespaces. right? Namespace is something when I'm going to create a whole lot of objects. I'm going to create cout, cn, endl, all these fancy objects I'm going to create, and I'm going to make them global, meaning available to everyone, right? But if I do that, doesn't that automatically mean that Mark cannot create an object with the same name as myself? Let's say I'm going to create an object. I'm going to create a variable, right? I'm going to create a variable called spoon, right? So I'm going to create a variable called spoon here, right? And it's global. Everybody. So anybody who uses the word spoon will be accessing that my variable. That means that they can't create a variable called spoon because they'll say, hey, no, you can't create this because Anand's already got a variable called spoon. So you can't do that, right? So I don't want that to happen. I don't want to be able to take away the freedom that you have to create your own objects. So what I will say is that any variable that I create, I won't create a naked variable like spoon, right? So in fact, what I'll do is every variable I create, I'm going to prefix that with Anand underscore spoon, right? Anand underscore x, Anand underscore b. So I, j, k. Any variable I use, I'm going to prefix my own name to it, right? That way, there's no chance everybody follows the same convention, right? Unless someone else has the same name, they have to use a different, right? So, but unless it's in the same project, right? So that is called namespace. And so what the C++ did was, since we're defining all these global objects, we're going to put them in a namespace, right? We're going to call them the standard namespace, meaning that you can still define your own variable called cout. But if you don't say that you want the standard cout, it'll use your cout. Now, in this case, we're not telling it that we want the standard cout, right? So there's two ways to do it. Either you can do what Eddie just did, which is saying using namespace standard, which means that any variable that you use, if it's not able to find it, it'll look in the standard space, right? So you can do that, or you can say, I don't want to do a blanket declaration up there saying that every variable I use, I look in there. No, what I'll do is if I'm going to be using certain variables, I'll specifically qualify each one of those, right? So you can get rid of the line, and one thing you can do is instead of deleting the line, Eddie, go to the beginning of line number 3 and insert 2 forward slashes, right? 2 forward slashes. And a forward slash basically means treat that entire line as a comment, meaning that treat that line and treat as though the next rest of the line doesn't even exist, right? So it's basically called commenting out code. So that the line is gone. So now instead of saying cout, say std : cout, right? So that means I want cout, but I want the cout that lives in the standard namespace, right? So I want to. Okay, now if you run it, no, it's std.cout, right? Console out. Yeah, if you run it, it'll run and say, hello, this is Eddie, right? Right. Now, one thing you don't see here is that it didn't print it properly, right? It printed, hello, this is Eddie, but it didn't print a new line after that, right? It printed, hello, this is Eddie, and that's it. And there's no, it doesn't go to the next line. And you can find out by saying, put another cout line after that, right? So copy that and triple click on the line, triple click on the line, triple click, 3 clicks, 3 rapid clicks. Okay, is this a Mac or a PC?
This is a Mac.
Okay, so hit Command C and then Command V 2 times. Okay, all right. Now go to the second one and then say, hello, this is line 2, right? Hello, this is line 2. Or whatever, this is line 2. Just say this is line 2. Now run that, right? Run that. All right, you see the lines are, it's not really printed them properly, right? There's no new line. So the way to insert a new line is to go to the end of the line, right? And say, and then left shift one more, left shift, say left shift, thank you. Left shift, yeah, and then space, but it's not endl. Endl is an object that has been created and it lives in the standard namespace, right? So you got to say std : endl. Right? Now if you run it, the first line will, it's on a line, but the second line still doesn't have a new line after that, right? So you can put the endl after that, but the second line will do it in a slightly different way, right? Now copy the second line and paste it one more time and into the third line, right? Copy. Okay. Now make that line 3. Now the second line, instead of using endl, let's use something that is similar to an endl, right? And endl does what we're going to do and a bit more that we don't want to go into the detail of now, right? Inside of the thing, right? Yeah, there you go. You're in the right place, right? There, yeah, but don't have the space there. Don't have because that space you can't see anyway, right? It's a useless space. It just takes up 1 byte, right? Okay, now if you run it, you'll see everything come out properly, right? Right, except, you see the cursor just flashed on the right of 3, right? That means there was not a new line there. If you run it again, you'll see before you run it again, before it goes to before it ends, you'll see the cursor flash after the 3. No, I think the first time I saw the cursor flash there after the 3, which means that there was no new line. Okay, that was the end of the line. So put the new line there too. Put the new line at the end of line 3, right? And then no, it's got to be new line. Yeah, /n. Yeah. Okay. Great. Thank you. All right. So there you go. 3 lines. Now let's just do one more thing, which is going to no, actually, let's do it with the Zaya. Okay. So all right. Hey, Eddie, we're going to let you go. Thank you so much for driving. Okay, I really appreciate that. So this is fantastic. All right. Hey, Isaiah, are you ready? Just open up a browser. Any old browser, right? Just open up any old browser. Are we going to go to what was it? Use CPP data stage? Let's just use CPP data stage again. Okay. Yeah.
Okay, I'm here.
Yeah. But open up your screen. Share your screen. Share your screen.
Oh, I can't. I cannot share my screen.
Okay. So what I'll do is I'll share my screen. Okay. So I'll share my screen, and then would I be able to share?
I can keep sharing if you need me to. That's not a problem.
Mm-hmm. Oh, you can continue?
Yeah, I can continue. It's fine.
No, I want Isaiah to code. You don't have access to a computer at all, say? There?
I'm on my laptop, but I just can't share because my Zoom is through my phone.
Oh, I see. I got to figure out some way.
Yeah.
Later, we'll figure out some way of doing it but be ready. We'll do it next class or something. Yeah.
Yeah, for sure.
So who was the next one? Who was the next person to come on screen? Srikaran. Yeah. Can you? Are you able to share your screen?
Yeah.
Okay, share your screen. Okay, but both Eddie and Isaiah, you got to watch this, okay? Because this is going to be crucial for the limerick quest, okay? And the limerick is all the way up to J. This is a second. Is it J? Is it number 2?
Yeah, it's in number 2.
Okay. All right. So got it. All right. So Srikaran, what we'll do now is let's do exactly the same thing that we did. In main, we're going to call another function. And then let's flesh out the body of that other function. And in that other function, we're just going to see out hello there or something like that. Okay. So let's create a function that says see out left shift hello there. Some function, call it whatever you want. Call it XYZ, right? So go right to the top. Get rid of that example program thing there. Yeah. Okay. And then say int, right? In fact, make it void, right? It doesn't have to return anything. So just say void space, call it some function, right? Test function or whatever, give it a name, get creative. Yeah, all right. You guys are not creative. Okay. Well, you're creative, but not, here on stage, you're afraid to be creative. Let's put it that way. Okay. So, all right. So he's called it a test function. Boy, is your font smaller than Eddie's font, or is that my glasses gotten weaker all of a sudden? Okay, all right, that's much better. All right, that's fine. Okay, all right, good. All right, test function, and then open close parentheses, right? And then next line you can open the brace, and then after that close the brace, and then go into the body of the function. We can start filling it in. Yeah. All right. So in the body of the function, just say see out hello test was called or something like that. See out left shift. Left shift, you got to do with the left shift. You got to shift things into the object. Okay. See out, left shift. See out on line number 2, say see out, and then left shift, shift, less than. No, I think yeah.
There you go.
Double less than. One more less than. Yeah, and then on the same line, say hello test function was called. Okay, within quotes you got to say hello test function was called. Okay, and then left shift end line also, right? Left shift. No, not right shift. Left shift. Space left shift. Yeah, I usually use a space because then it's easier for the compiler to split things up. Yeah, left shift. Left shift. Yeah, two. Yeah, and then Yeah, endl. Now this time, instead of qualifying cout and endl with std colon, because already 2 times you've got to do std colon, right? So right at the top, very first line, you say hash include iostream in line number 1. Say hash include iostream. Hey, Eddie and Isaiah, are you guys following?
Yeah, I'm watching.
Okay.
Yes, of course, I'm paying attention.
All right.
But
Okay.
I get what we're doing now.
Yeah. Okay. All right. Good. No, but I know. So far we've done already. Okay. But now what's coming up next is going to be new. Okay. So stay in step. Okay. All of you guys.
Taking notes. Wait, can I have a question?
Yeah. Sure.
Okay. So I get the C out. Is the C in just the same thing, but C I N?
We'll use it. Why don't we use CN today? Right. In fact, do you want to let's make a Srikuran use CN in that function? How about that?
Yeah, that'd be good.
Okay, good. All right. So iostream has to be within angle brackets. Within angle brackets. iostream on the left-hand side, you need the less than, and the right-hand side, you need to be, yeah. Okay. And then on the next line, blank line after that, blank line, and then say using namespace standard, right? Using space, namespace, std space std semicolon, right? And I think that says to the compiler that if I use any variables like cout and endl and you can't find them in local scope, look for it in the standard namespace process. All right. So in main, just call test function, right? In main, just call test function. Oh, you got to return 0 too, but you can do that later. Okay. Return. No. Yeah. All right. Above return 0, call test function. Yeah. Test function. Open close parentheses. Semicolon. Okay, now that should be able to compile and run, right? If you omit the semicolon, you should try it. Okay, try running it without the semicolon. It'll tell you, right? It's syntactically incorrect because the compiler requires you to tell it that that's the end of the statement. The only way you tell it that's the end of the statement is giving the semicolon, right? See, you can see the red lines. Oh, there, you don't have a semicolon on the previous line too, right? So you got to put a semicolon there and a semicolon here. Okay, now you can compile it. Okay, so now you see hello test function was called. Now what I wanted was let's make test function interact also with cn, not just with cout, also with cn. So in fact, what we should do is in test function, go to your test function, and let's actually call it something more sensible. Call it intro.
You don't need a semicolon after the iostream.
Oh yes. Thank you. Call it intro. All right. So intro. The first thing in intro is going to be print the prompt. Say hello. What is your name? No. The first line is going to be cout. Hello. What is your name? Oh, what is your favorite color? It's yeah, or whatever. You can ask any question. Yeah, favorite color. Right? And then because it is a prompt, you're expecting the user to type something in, right? And this is again something C++ doesn't care about, something the compiler doesn't care about, something that I care about as a human, right? Which means that maybe other humans also care about it. So when we're coding for humans, what we do is that I'm asking them a question. It's nicer for many humans to type the answer on the same line as the question is asked, right? Imagine, right? Think through many online forms you've filled or exams you've answered. If you have multiple choice questions, it's easier, it makes more sense to type in the answers on the same line as a question, right? It makes it cognitively, it lightens the load by 0.1%, please, right? So what I tend to do is when I have a question like that, after the question mark, I put a space. After the question mark, I put a space, and then I don't give it an end line, right? If you put the end line, now I'm going to accept input from the user. It's going to accept input on the next line. No, let me accept input on the same line. So question mark, space, and nothing else after that. Put a semicolon right there, right? Yes, okay. On the next line, we're going to do what Isaiah wanted. We're going to talk to the keyboard and get input from cin into, right? Okay, so you say cin, right shift, right? So left shift is going to the screen, right shift is coming from the keyboard. Right shift is 2, right? Now I want the output as a string from the user. So in order to get output as a string, I'm telling read the keyboard and take what the keyboard gives you and put it into the variable. But what variable? I don't have a variable. So let me go to the top of the function, to the beginning of intro, right? And create a variable. Tell the compiler that I want a string variable, right? So let's say string space color, right? Semicolon, right? And a space, because I like to have the the declarations separated from the logic, right? So I usually have a blank line before the, yeah, there you go. All right, so cn, now I'm saying, read the console, and whatever the user types in, get the word from there and put it into this variable called color, right? Color, put it into color, right? So, right, there you go, color. There you go. And Peter's here too. See, he's going eating. He's being forced to eat the. Oh, he took the. Oh, there he goes. All right, I think he's eating the apple. There you go. That's good, Peter. Not good, but I need to get rid of the apples before I can start giving you nuts. Okay. All right, now you can say some wisecrack there on the next line. Now you've got the color from the user. You can say, oh, how uncanny! I knew someone else who liked. Right. So something like that. Right. So I knew someone else. So see out, left shift. Right, and say I know someone, or do you know Judy? She also likes, right? That's that's interesting, isn't it? When you talk to someone and say, hey, that's really nice. That's a nice shirt, man. Where or you say, where are you from? And you say, oh, I'm from Argentina, right? Oh, do you know Horacio? He's also from Argentina, right? Yes, right. So people say, from the same country, you got to know the other person. So we'll say, oh, then you should know Judy. Then you should know Judy. She also likes, right? Say, then you should know Judy. No. Then you should know Judy. Then you should know Judy. Then you should know Judy. She also likes. Space, and then quote, double quote, right? And then left shift one more time, and then color, right? Left shift. Yeah, two. Left shift is always two less than. Okay, two less than. Two. No, not right shift. Left shift. Space, and then color, and then left shift and end line after that. All right. Now let's also make that a grammatical sentence, right? No. Left shift is two less thans, and then put a space. Yeah, two less thans, and then make that a grammatical sentence. Then you should know Judy, and then a full stop, and then she also starts with a capital S. Right. All right. Okay, and then maybe before the endl you need a period, right? Before the endl you need a full stop, right? So instead of the endl, give it a string, right? Give it a quote, period, /n, close quote, right? Instead of the endl, and because it's shorter now. It's shorter now to just put the /n interpolated in. Yeah, /n. No, not forward slash, backslash n. Right? That puts the period and then the new line. Okay. Now if you run that. Isaiah, are you following? And Mark had a question. Hang on just a sec, Mark. Hey, Isaiah, are you following?
Yes, I'm following.
Okay, so what this is going to do is it's got a string called color. It's got a variable called color. It's going to print the string, what is your favorite color? And it's going to read the keyboard and get the person's color. And then it's going to say, do you know Judy? She also likes the same color, right? That's all it's going to do. It's a little joke, right? So now if you run that, it's going to do exactly that. Oh, wait, where do you have these triangles? Where do you have the yellow triangle? Go to the top over the triangle.
That was from before.
Left over from before.
Oh, I see.
That was when they had the semicolon.
Yeah, all right. Okay, run it. Okay, all right. Now, not Srikaran, not you. All right, let's pick someone else. Let me make the screen bigger because I think not all of you are here. Okay, how about Maxim? Maxim, give him a color. Maxim, give him a color.
Yellow.
Yellow. All right, Maxim likes yellow. Oh, you should know Judy. She likes yellow too. All right. Okay. Now there you go. That's a little fun program for you. So that means that everybody who likes yellow know each other. It's so funny, right? But you can actually make a case for that for some really incredibly rare color. It's to take an extremely rare color which you can't even pronounce, right? So only like 3 people in the whole world know that color, right? And then if you ask someone and says, "I know that color," then you can immediately make that logical, conclusion with a very high probability. Oh, then you should know Dr. XYZ. He also likes that color, right? Because there's only 2 people in the world who know that color, right? So there you go, that kind of thing. All right. All right, so there you go. So that's a very simple program that should hopefully form the basis.
Yeah, I like it.
Yeah, Isaiah, you want to take over and do the next one, or are you good with this? And what time is it, by the way? Oh boy, it's 9:25. I've been talking for an hour and a half. Yeah, no wonder. I need some water. Okay, so you guys should basically just feel free to play around for the rest of the class today, right? I should give you half an hour to play around on your own at the very least, right? So what you should do is take 5 minutes each, and each of you should come on board, right, on stage, write one very simple 2-line function, just like this. Use this as take a screenshot. Take a screenshot if you want. Use this as a template, something like this, but not similar, right? Use your own joke. Use anything you want, right? 5 minutes is all you get. So you got until 10 o'clock. That's like at least 5 people, right? Each of you come on stage, write a program, run it, and see the result, and then hand over the stage to the next one. You can form a line, right? And I'll watch the video later and see who's participating, who's not, and so on and so forth. But it's basically up to you, right? Is that okay with you guys? You can always call out to me, right? I'm going to be off screen. I'm going to be out there. Maybe you can catch a drink or something, right? But you can call out to me if you want, right? But are you guys okay with driving the car yourself? Or the engine, the train yourself? Yeah? Well, Ricardo's just faintly nodding his head. Nobody's even talking, right? Yes or no?
A little bit.
Yeah.
As long as we got Mark.
Yeah, okay. Well, you can call out to me, okay? You just call out to me if you're stuck. Yes?
Yeah, we'll
Okay,
talk.
so who's the first person?
We'll call out whenever we need help.
Go on stage after I go off stage. Who's going to come on stage?
I could go.
Chris. Okay, good. Chris. Okay, your responsibility is you do the first 5 minutes, do your program. Before you got to find someone and nominate someone and get them to take the stage before you hand over. Okay, is that okay? Turkey. Turkey, is that your first name?
Yeah, that is correct.
You go after Chris.
Okay.
All right, so the person that hands off needs to hands off to the next person. If nobody has been selected, you got to select someone, right? Ask for volunteers, pick a volunteer if you have to, right? And then hand over to them and then take off. Is that okay with you guys? That way we have a chain, a continuation going, okay? So the following people are not allowed: Mark, Elizabeth, Isaiah, Eddie, who else went today? Right, Srikaran, okay? No, none of you guys allowed to volunteer again today, okay? The rest of you guys feel free to volunteer and take, no more than 5 minutes, right? Not like me droning on and on, but take your time and feel free to play around, okay? The important thing is to play around. Why are you so, right? So it's like, in those days, it used to be so hard to get a computer. And we used to be so grateful to people, to older people who would give us like 10 hours, not 10 minutes, 10 minutes to play with their computer while they were doing something else, right? And say, hey, play around with the computer. And now you got a computer. Everywhere you look, you can get a free computer, and you're not doing that. That is like taking a small kid to a playground, right? So because, think about it. In those days, you take kids to a playground and they're just waiting to be let loose, right? Let go of me. I need to go and play. Now you got to take them to a playground and say, here, you got all these fantastic things in front of you, go and play, right? But they know they're not going, they're just holding on to you. They no, I'm not going to go, mom, don't go, right? Holding on to you. This is a wonderful playground in front of you. That's how it is, right? In those days, we used to just plead with older people to give us access to technology, because technology was so valuable and so fun and valuable. Now it's fun and it's not valuable. Why is it not valuable? It should be as valuable as it was to us. And because people have lost the magic of technology is lost on many of the youngsters, right? Reclaim magic.
Fans only.
Yeah. I'm sorry. I didn't mean to go off on a spiel like that. All right, I'm just going to go off screen. All right, it belongs to you guys. All right, so enjoy the rest of class and call out to me if you're stuck. Okay. All right. So all right, bye.
Hey, our teacher don't like the Generation Z. You can hella tell. Hella funny. Hey, so who's up first? Chris? Are you gonna share your screen? Hello?
Yeah, I could do that. Yeah.
Oh, yeah, thank you. I actually probably need to walk through with somebody. I can't share the screen, but I kind of get what the second program did. But I still am a little rusty.
Do you guys see the screen? All right, so I think this should run good. Let me see. So 1, 2, okay, cool, yeah. So basically what this is doing, it's prompting the user to pick a number. And then I made 3 variables. Wait, do you guys hear me?
Yeah.
Yeah, we can hear you.
Okay, so I made 3 variables. these two hold the user input, and then this one just adds the user input. So I prompt the user for a number, it gets put into X. I prompt the user for another number, and then it gets put into Y, and then the answer is just X plus Y, and then I just see out the answer right here. So yeah, that's my program. You guys,
you know, the professor is going to be like watching the rest of the video, just like, you know. Yeah.
do you guys have any like other like questions about my program?
Yeah,
We
Chris,
can't hear you. You're muted.
and Chris, I have one quick question. What's the meaning of CIN? Is that that new definition or?
No,
That'll
that's
be
the
console
input.
in.
It's the
Input, so
standard C input function to get input from the keyboard.
I see.
Yeah.
Thanks.
So the C out stands for console out, and then C in will be console in.
I see. Thanks.
Wait, do you guys not hear me?
Oh,
Yeah, we
sorry.
hear
Yeah,
you.
we can
No,
hear
we
you.
can
We
hear
hear
you.
you.
You're
Okay.
good.
Yeah, sorry,
Thanks,
I didn't
Chris.
know. But yeah, so
believe they
C
hear
Yeah,
in
hi,
puts
you guys.
the
Sorry
It's
about that.
cool. It's
I didn't know I was
cool
on
because
camera.
you're using the like the arithmetic functions as well. So that's like also something we're supposed to learn.
yeah, so
from
C in
this
basically puts
module.
the input gets the input from the user and then puts it into a variable.
yeah, I have a question.
Yeah, what's your question?
So you don't have a return statement, right?
Oh yeah,
What?
it's supposed to be down here, return 0.
Yeah, I think so.
Any other
Why
questions?
do you need the return 0?
That just kind of basically means that the program ran okay. And
The
it's just,
integer mean, right? So we
Yeah,
have
so
to have the integer out, like return an
so
integer.
our main like has the integer like it like because it says int main, it's supposed to return an integer value. And so basically return 0 is like a signature at the end of the program that signifies that you were able to run your program without any errors, because 0 means false in Boolean, like 0 means false and 1 means true. So basically at the end of the program, like you ask the program's like, oh, like did we have any like errors when we were running this program? And then 0 means no, we didn't. So everything is okay. Yeah, that's like the short answer. The answer we could have talked about before.
No, I got it, but I was just wondering because his program worked fine. I was like, is
Yeah, you don't
return
need
0
it. You
a
don't
necessity?
need
Yeah,
it.
you don't need it. Yeah.
No, you definitely don't. But it's just like you put it there because it's just like correct way to do it.
You don't have to.
I have a question like what's the function of the first 3 line, like include string or using namespace std?
I think this includes the library, and then I don't think you need this.
Yeah, I don't think you need string when you have iOS stream.
Yeah, but when I opened the website, it was already there, so I just left it. But all you really need is include IO stream.
Basically, IO stream allows you to use cout and cin. Otherwise, the computer won't know what you're talking about.
Yeah, there's also like I think there's a math library as well. So you do like hash include.
Yeah, it's like hashtag include.
And then those give you like
math.
a whole library of just like predefined math functions that are like more complicated if you're just trying to write them out like by
it
hand.
includes like the square root and the power of a number and stuff like that.
You don't have to do that manually. You can just like use the function that's predefined in the library, math.
And also, what about the namespace on the next line?
So this basically makes it so that I don't have to do this each time.
So
say if
print, right.
So if we were to like comment this out, this wouldn't be able to run. So like if I try to run it, let me erase that.
No, we just stopped right there.
So if I try to run this, yeah, see how it doesn't let me. So if I want to add this, instead of using namespace, I could just do this. But like you can kind of see it takes a long time.
Thank you.
Wow, that's a nice shortcut. Thanks.
Yeah, but like it's considered bad practice to use it, but I think for our class we should be fine just using namespace.
Yeah, I also my partner also told me it was bad practice to do the namespace. So like if you're like coding something like a bigger project than something that's just like a simple tiny program, you're gonna just want to use the STB individually.
Yeah, that's just because we're beginners.
Yeah,
Like everyone uses that for shortcuts.
Yeah.
Yeah, exactly. Does the I forgot who was going next. Do you want to take over?
You're supposed to choose.
Does anyone volunteer or?
Can take
I
over
think it was
next.
me
I got the similar. Oh, you want to go next?
I thought you're supposed to choose.
Oh well, anyone who volunteers can go ahead.
Okay, I'll go next.
All right, go ahead. I'll stop sharing my screen now.
So, and everyone see it?
Not yet. Or yeah, go. Yeah, I see it now.
Okay, so in this program in main, it takes an input from a user and it just calculates the tip from a function called tip. When it passes it by multiplying it 1.1 for 10%, 1.15 for 15, and 1.2 for 20. I left comments. So if you give it a run, let's say 50. Awesome. Any questions?
Pretty cool.
Yeah, can you explain your integer x count out type total, that whole second line? I'm not quite understanding it.
Definitely. So we define a value here as an integer called x.
And that would be 50, correct?
This is based on the user input. If we go to line 17 here, we
Yeah.
see that we asked for an input from the user, and we're going to send it to x. So
And
if you run the function.
Oh, so whatever
Yeah,
you
so
put
at this point, yeah, that is correct.
Oh, okay.
So
Okay, that's,
I guess
yeah.
if you were to like submit this code, maybe a professor would say, "Oh, your like program is perfect, but make your like variable like more descriptive or something." But
Yeah, I
for
was
the
gonna
purpose of
say,
this
Nah,
class,
it makes perfect sense. I was just checking in terms of like the math in the cover.
yeah,
so,
yeah.
so I
But
can know how to write it.
so instead of like I, you could put like just interest or something, you know, or I don't know what I would be. Yeah.
Or just
So-
total.
Yeah, or total, yeah, or something. Because it increases the readability of your like code, like just in general. For like, from what I understand, I'm like a total newbie, but like from what I understand, like the more like descriptive you can make your variables, opposed to just using like single letters, the better for, like, you know, when you get into like really complicated programs and you're like messing with like a ton of different like variables, just to get in the habit of doing that. But for this class, for this like moment, it doesn't really matter. But
Awesome.
yeah, it's I guess I think that's what I've been told.
One more question. What's TIP?
What IP?
Line 18. That's the line you're on.
It's tip, the function tip. If you go top here on line 6.
So he's calling the function here, and he's passing in the user input through x right there.
Okay, so C is out, X is integer. What's tip?
Tip is the function. So if you look at line 6, we define the void function called tip.
Tip is the name of your function? I'm slow. Thank you.
Anytime. Awesome. Any questions?
And that's the initial total. Okay. Beautiful code, by the way. Thank you. You taught me so much.
Anytime. So who's next?
I think you have to choose since
next.
no one else was
Awesome.
gonna.
I'll choose Christopher. Oh, you already went.
Yeah, I already went. Yeah.
What about Maxim?
We got in the class, right?
Yeah, I see him online here. Maxim?
You're just
I'm
unmuted.
just, yeah, I'm lost, kind of.
Oh, well, see if we can help you.
Yeah, we work together.
So might want to.
So the first thing you want to include is the hashtag
IO
include
stream.
IO stream.
What?
Include IO stream is the first thing you want. Hashtag include and then red parentheses IO stream in the parentheses. Yes.
This
Now,
keyboard thing, or what?
Namespace is next. 2 lines down. Yes.
Using namespace.
Yeah, using namespace standard. Using.
And
No,
it's just
STD.
STD.
STD. Yeah. Oh.
And then the semicolon. Exactly.
So Maxim, I got a question for you. Last time you used a calculator, do you remember what you used it for?
It was for Chem 1A.
Is it complicated to throw together a program to do that? Well,
Yes. So what are you trying to do?
I have no idea.
What do you want to make a color? Do you want to do a name or do you want to do a number?
We can just do number.
Okay. So C out, right? All right.
How about a program that calculates
Or void create the
number
program.
And then you can call the function whatever you want. So like just think of something.
Player, genius, happy.
Hey Maxim, do you remember Avogadro's number and how to use it to calculate the number of molecules in something?
Yep.
Yeah.
6.24 times 10 to the negative 23.
I thought it was 10 to the regular 23.
Yeah.
Right.
So
It's regular? I thought it was to the
I
negative.
thought it was regular. Yeah, because they're so small.
Oh, you're right. Avogadro's number. I'm thinking in the reverse. You're right. It's to the power. It's to the power. I'm thinking of what's the opposite of it? It's one of those other numbers. But I don't know. I keep failing that class though.
Yeah.
I see why. I don't remember.
But yeah, I mean, if you find yourself doing calculations like that on a regular basis, if you write a quick script to do it for you instead, you can submit that probably on the side, and the teacher probably won't get too upset. Just an idea for a program since we're here.
Oh, you're smart. You're smart using what you know.
Anyways, so I guess the name for that would be like moles, void moles, open close parentheses.
So after void, you just put the name of your function. So you can just put void space dot moles and then just open and close parentheses, or not the dot. So moles.
Like regular parentheses.
No, you need a name for your function. So any name.
So kind of like how you see int main, main is the name of the function, and then the open and close parentheses. So you can kind of just follow the int main. So void moles, open and close parentheses.
Like that?
And then,
or...
yeah, exactly. And then your curly braces.
I don't know if this helps, but if you think of functions like from math, f of x, that's essentially what it is. You're naming the function, and then inside the parentheses later on, you're going to be putting an input.
Oh, okay. So do it for the curly brackets, do I just put it in the same line as the void or the next line?
That's a stylistic thing. It'll run either way if I'm not mistaken. You know, there are two kinds of
That
people.
function thing's a good way to think about it. Like blew my mind. It's so true.
So the thing is, you're going to put your function inside the curly braces. So you kind of want to make some space for it. So get the last curly brace and just hit enter a few times, and then just put your curly brace. Exactly, and then in there you're going to put your function.
Might be helpful to declare Avogadro's number as like just a number at some point.
All right.
So hit tab.
Since we don't know that much about data types, we'll just approximate the crap out of it by saying it's like 10 or something.
All right. Yeah.
Hey, I'm back. Everything okay?
Yeah, we're just going through we're just helping Maxim with a function that he's trying to make.
Oh, cool. Okay.
I have another function if I could go after.
Yeah, sure. Ricardo?
Yeah.
Okay, yeah. Hey, what time is it? 9:47. Is everybody okay? I'm happy if Ricardo wants to take over the screen after this. Yeah.
I have another class after, so I'm not sure if I could stay the whole time.
Yeah, sure. The thing is, you can those of you who want to can take off and then watch the video too, right?
David also mentioned that he has something ready to go.
Yeah. So you guys can watch the video to see what Ricardo and us did.
Okay.
Alrighty. All right. So take off those who have to, and then Ricardo will take the screen, and then we'll drive.
Are we gonna do the moles one?
Hmm?
Are we still gonna do the moles function?
Oh, do whatever you want. Yeah. What is this mold function? You're doing a mold?
I believe Maxim was sharing a screen, and just to get an idea out there, asked him what the last time he used a calculator for, what he used it for. They mentioned something involving chemistry, and one of the first calculations.
Oh, mole. A mole, you mean?
Moles.
Yeah. The molecular weight in grams, I think, isn't it?
Well, Avogadro's number, so like the 6.0
Okay,
something times 10 to the 23rd.
So the idea is to find the number of moles that you have in a certain mass.
Oh,
you take the mass and divide it by the.
Oh, that's really cool. Yeah. We can do that. Yeah. Using Avogadro's number. Oh, except I don't know if we've gone over the way of declaring it. A floating point exponential number, scientific notation numbers, right? I'm going to show you really quickly. But basically, you want a way of in which you can tell the compiler this quantity is 6.023 times 10 to the 23, right? The number of atoms per mole. 6.023 times 10 to the 23. Isn't that the number of atoms? Is it number of atoms per mole? No, number of molecules per mole.
Yeah.
Right? Number of molecules of a substance per mole, right? If you took oxygen, for example. The molecular weight is 16, isn't it?
It would be about 16 grams a mole.
Yeah, so 16 grams of oxygen will have 6.023 times 10 to the 23 molecules of oxygen in it, right? And that number doesn't change regardless of, because the molecules just get more tightly packed, and so they occupy the same. I don't know, whatever it is, right? Yeah, and I think that's a very interesting thing to calculate too, right? Because it is an indication of the amount of matter, not the density, amount of matter itself contained in the substance. Yeah, go ahead. Moles. Moles. What are you trying to calculate? Oh, you're trying to calculate the amount of the number of moles in. I see. Okay, so you can say float double use it because it's a big number, right? 10 to the 23 and all. It's going to be a big number, so we'll use double space. Yeah, give it 2 spaces to indent in. I think it's much easier if you 4 spaces to indent in. No, from the beginning of line.
Okay.
Left side, not right.
Yeah, this is nicer. I think I find easier on the eye for many people. Yeah, double space Avogadro underscore number. Underscore number equals. Yeah, space equals space. Right?
Oh, okay.
Yeah, separating the operators is just an aesthetic detail. It's actually enforced in many modern languages like Swift. You have to have spaces, or symmetric at least on either side. All right, equals 6.023. I think that's the correct value.
3, I think so, yeah.
Yeah, 6.023. E as an exponent.
Yeah, 0.22.
Yeah, okay. All right, we'll just use this for now.
Yeah.
Yeah.
Okay.
Even lowercase e or uppercase e, doesn't matter. E 23. E 23 or E plus 23?
What?
E 23.
All right.
No, E 23. E 23. 6.0 E 23.
6.0
E 23. Oh, wow, your editor is like totally screwed up. You got extra spaces in front of the double and all. And semicolon right there.
All right.
Yeah. And get rid of the double indentation. Why do you have double indentation there? Get rid of one of the levels of indentation. Great. Okay. All right. So that number is 6.023. No. 6.023 times 10 to the 23. You forgot the 023. I think we overwrote that. Yeah, 6.023. 23.
Then.
Oh, your keyboard or something is set to overwrite mode, not insert mode. Everything you type is just overwriting whatever is there, not inserting it there. Is there an insert key on your computer?
Yeah, it's on the right hand side, I believe.
All right, so yeah, type 23. Type 23. Okay, there you go. All right, okay. So what that means is 6 is scientific notation. All right, everything after the E is 10 to the something. Okay, so 6.023 times 10 to the 23. That's what this means. Is everybody okay? Hey, your indentation is weird. See, this line where your cursor is at right now is currently indented properly, right? The previous line has got one extra space. Do you see that?
Yeah, because.
Yeah, clean up the space before the double. Before the double, yeah, get rid of the space. No, you got rid of the tab. Yeah, tab now. Good. I think that's good. All right, so now you want to calculate the number of moles, right? And I guess above the function moles, it's useful to insert a little comment, right? So go to line 4 and hit enter. Go to line 4, hit enter. Right now, we're going to write a small comment that tells people what this function actually does, right? Which will also give us a guide as to how to use this function, right? Because we haven't even written the function, the comment is going to guide our own development of the function. Yeah. Okay. So above the mole function, write a comment, right? On line 5. On line 5, open two forward slashes. Yeah, 2 forward slashes, right? And say space. This function accepts the number of grams of this function. We'll fix up the spelling later. Accepts the number of grams and the molecular weight of a compound and returns the number of moles of that compound. Yeah, you split it up into 2 lines and all, right? Because it's running over. Yeah, you can clean it up. Where's Peter? He was here just a minute ago.
Hi, Professor.
Oh, he's coming back. For whatever reason. Oh, I see. Wow, he's brought back Ash as well. There's 2 of them, right? They originally they were competing with each other, and now they're friends, and they basically share the food on the same plate, right? On both sides. So it's kind of cool.
What are they, Professor?
These regular wild squirrels. So yeah, last quarter was the time when we started doing these Zoom lectures. And then I was doing the lecture over there. And then during the lecture, I noticed that, there was a wild squirrel perched on a branch just looking at us. And then we got close by and it ran away. And then I started leaving out a little bit of food for it. And then he used to come back at predictable times. And then he started getting tamer and tamer. So I have to exercise extra care to not make him any more tame. So I try to not give him food sometimes. Yeah, now he's, he brought his friend along too. So there are two of them. Oh, anyway, what were we doing? Yeah, okay. So you split it up in two lines. Split it up in two lines. Go in front of the compound, compound and hidden. Wait, yeah. Wait and put it on the next line. Put it on the next line. Yeah, /, 2 forward slashes. Okay, this function, fix up the spelling for function, function, the function, function, the previous line, line 5. Yeah, function. CTION. You can rid of the UT. Yeah. One more. Yeah. Okay. Great. Accepts the number of grams and the molecular weight of a compound and returns the number of moles. All right. So it is not void. It is going to be returning a float. Right. It's going to be returning a float or double. Make it return a double.
So instead of void, I put double.
Yeah. Instead of void, you put double. Exactly. Thank you. Is everybody following along?
Yes.
Okay. All right. Now, there you go.
Why is it?
No. What happened? It overwrote the name of the function.
I don't know.
No. Hey, wait. Don't.
Yeah,
you're going too fast. All right. Just hit space. Hit space one time.
Yeah.
Okay. Calculate moles. Calculate moles, right? Yeah, don't call it moles because moles is not a doing thing, right? It's a noun, it's not a verb. So calculate moles is a verb. Now, because this is a function that is supposed to do something, you ask it to do something. The name of the function should be a verb, right? It shouldn't be a noun. A noun means it is something, right? It is not going to do something for you. So these are things that you basically, but the compiler doesn't care. The language doesn't care about these things, okay? All these things I'm suggesting are basically for humans, right? But to make it easier for us to read. So when you're doing when you're writing a function which is supposed to do something, think of it as another human being. So give it a verb, right? So say calculate _ moles. Calculate _ moles. Right? You get rid of the semicolon after the L. Right now in the comments you said it takes two things, right? It takes the weight of the compound and the molecular weight, right? So
the number.
So it takes two parameters. It takes two parameters. It's given two things. Right? So inside of the first line on line number 7, right? On line 7, inside of the parentheses, we're going to tell it when someone calls you, you get given two parameters, okay? So these are things we will actually go into in later classes, right? When we talk about functions and parameters, but anyway, it doesn't matter because we're not really in official class time, we can talk about these things, right? So the first parameter here, calculate moles, is going to be the number of grams, right? So you say double grams. Grams, yeah, comma, and then it comma, not closing parentheses, comma, space. Again, it just overwrote that thing. Your thing is switching between overwrite and insert, well, willy-nilly. Now I'm pretty sure it's in overwrite mode now. If you whatever you type is just going to overwrite what's under it. Yes.
Probably.
I think there's a key you're hitting accidentally. I think there's an insert key you're accidentally hitting and it's flipping and it's toggling this overwrite mode. Yeah. Anyway,
because I'm using an external.
Right. So grams, comma, after the comma, type in molecular weight. So say double space. Yeah. I don't see the cursor. After grams, comma, space.
After grams.
comma,
space.
comma, yeah. I don't see the cursor at all. Nothing is blinking there. What's going on? Click there.
Because I had been using like an kind of like an external keyboard.
Yeah, so
with,
the keyboard is not connecting then.
One sec.
Never mind. Type something visible in. All right. Say double. Say double DOUBLE.
Yeah.
Yeah. See, your keyboard is not communicating with the machine. Anyway, I can describe what needs to get done. You guys can do it in your spare time and then post it and share the code. Yeah.
I can take space if it helps.
Hmm?
I mean, I can share my screen to continue the coding if that helps.
Yeah. Okay. Maxon, you want
Sure.
Chani to do it?
Sure.
Yeah. Okay.
Double molecular.
Underscore. Underscore. Hey, how did you get this code immediately like this? Was it you clicked on the share URL or something?
I mean, you mean all of this?
Yeah, all of that. How did you get it?
I was coding at the same time. Meanwhile.
Oh, I see. Okay, I thought I thought what happened was without us noticing, Maxim clicked that short URL and it provides that link, and then you click on the link, you get the code immediately. It's a shared URL. So I thought you did that even without me noticing, and I thought I must have spaced out completely for a few seconds. Okay, all right. You've been typing all along. Okay, yeah. Awesome. All right. Okay, double molecular underscore weight. Okay, all right. Now this function has got the number of grams of the compound and the molecular weight of the compound, and it knows what Avogadro's number is. It needs to calculate the number of moles of that substance in that many grams. Yes. So, for example, if it was 16 grams of oxygen, it is 1 mole of oxygen. Yes. I don't know. I'm not 100% sure about these molecular weights. So you guys got to correct me, right? Assuming that 16 is the molecular weight of oxygen, is O2, right? So 8 plus 8, 16. Yeah. So it's 16. 16 is the molecular weight of oxygen. So 16 grams of oxygen, right? Someone actually counted with a needle, right? 6.023 times 10 to the 23 molecules of oxygen inside of it. Okay, and, right? So what is 16 grams has 6, right? So it's basically a simple ratio and proportion thing from arithmetic, right? 16 grams, 6 million molecules, right? We'll call it 6 million, right? It's the 6 big ass numbers, right? So some x molecules, right? X molecules, right? A for Avogadro, right? So 16 grams, A molecules, G grams. How many molecules? So all I need to do is find out how many molecules per gram. How many molecules per gram, right? 16. So A grams has 16 molecules. So for each gram, you have A divided by 16 molecules, right? A 16th of A grams, right? A 16th of A grams is constituted, right, by each hang on, a 16th of A molecules. I'm sorry, what was I doing, right? So a 16th of A molecules, meaning that if it's like 6.023 times 10 to the 23, that many molecules, right, divided by 16, because that's the molecular weight of 16 oxygen, right? So whatever you get, maybe you get 18 trillion. Right, so each gram of oxygen has 18 trillion molecules. Right. Well, when we do the expression, it will be perfect sense. Right, it'll make.
I think the easy way to do it is just divide grams by molecular weight, and then later multiply by Avogadro's to get the number of
exactly. Just do do it. Yeah. Hey, so what Mark is doing? No. This. So by the way, Changyi, you type the moles of the molecule equals. Here is a very good thumb rule that I have found served me really well. Is this function called calculate moles is an interior function, meaning it is not a reception area person, it is a mechanic floor person, right? They cannot talk directly to the user. They cannot do C in and C out. They can talk back to someone who called them, but they cannot talk to the user, right? Okay, so our receptionist is always main. Okay, or certain functions that main has nominated, saying, okay, I recognize you all to be sufficiently well-presented individuals who can talk to our customers. Okay, so they get moved into a lobby. So otherwise, only the receptionist can talk to customers. Okay, so have a function called main underneath, and don't have the cout line there. Okay, don't have the cout. Instead of the cout line, what this should do is simply calculate the number and return it. So let's do what Mark suggested. Just go into that Avogadro function, the calculate moles function, right? And say return.
Calculate mole function.
Yeah. Or you can say a double n moles equals, or double num underscore moles equals. Is it number of function accepts number and what does it return? Returns the number of moles. Okay, returns the number of moles equals.
The grams divide molecular weight. Grams divide molecular weight.
Yes. Grams divided by molecular weight times Avogadro's number. Is that right?
Well, for just the number of moles, you don't multiply by Avogadro's number. You multiply.
That is for the number of molecules, right? Yeah. Yes. Yeah. Get rid of the times Avogadro's number. I was getting the number of molecules there. Thank you so much. Yes. Okay. Right now you can write another function if you want later on that says count molecules in. Right, and give it a certain number of grams and the molecular weight, and it tells you how many actual number of molecules are there. There you multiply by Avogadro's number. So here we don't even need Avogadro's number, right? We don't need. Isn't that right? We don't need. We don't need line 9. Yeah, right.
Technically, no.
Yeah. So let's no. Don't get rid of it. I want to use it. Let's change the name of the function. Let's call it instead of calculate moles, count molecules. Yeah, I think that makes more sense. Yes. Okay. All right. Now you can multiply by Avogadro's number and return the value. Is everybody okay with this?
I would put Avogadro's number. But I'm just worried about the order of operations is all.
Oh, you mean the order of operations?
So I'd put like a parentheses around grams divide molecular weight.
Okay, right.
And
yeah,
then
that is fine. Go ahead and do it. It makes it certainly no. He says no. Put back what you had. Control Z, Command Z, or Control Z a couple of times. Get back what you had.
Okay.
So what Mark said was just grams / molecular weight. Put that within parentheses. Makes it easier to read.
I see.
Right? Because even otherwise we know, because given our
maybe this would be the denominator. I see.
Right. But even otherwise it's okay. We know that, right? Because of precedence rules, we know that PEMDAS, right? PEMDAS, we know multiplication and division have the same order of precedence, right? And then it's just the order in which they're encountered. So division is encountered before the multiplication. So the division will be done before the multiplication. And because the multiplication is by a big number, you'd rather it comes later. And so, but this is better, right? What Mark suggested is a better way to do that because it saves like 25 milliseconds. When an expert programmer is scanning the code, they'll know immediately. Bam, like that. Yeah. All right, good. That's it. You can just return no, it's not molecules number. It is num molecules, right? It is num underscore molecules. Num. Underscore, yeah, NUM or number of molecules, whatever you want to call it, right? Num underscore molecules.
I see.
Right, and then you can return num molecules, or you can basically just return that expression itself without having to calculate it and store it in a temporary value. You just return that itself, right? On the next line, just return num molecules. Yeah, and then in main, you can ask a question to the user saying, what is the molecular weight of your desired compound, right? So see out on table of thing. What is the molecular weight of your desired compound? Yeah, question mark and then space and a space because it feels better to type in your response after space. No, before the yeah, there you go. All right, so a semicolon right there, semicolon. You don't need the space after, yeah, semicolon. Right, on the next line you say cin and then accept the input into an integer that you will float, double, right, double. Say on top inside of main, you have inside of main after the brace in main on line 15, hit enter. Yeah, enter, and then say double we want three things, three double quantities, right? Let's say the first double quantity we want is, what is it? Weight, molecular weight, right? So say double molecular weight, double underscore, double space molecular underscore weight.
Why don't we use the grams up here?
No, that's going to come next. That's going to come next. Yes.
Oh, okay.
Yeah, double molecular AR underscore weight, comma. Yeah, on the same line, you can do a comma, grams, comma. Number of molecules doesn't make sense to make it a double, right? Well, make it a double, we can cast it to an integer later. Okay, so you say number of molecules, num underscore molecules, yeah. Semicolon, right? Enter. Okay, now you can accept the user input into the molecular weight. And then also fix the spelling of the molecular in the prompt.
In the prompt?
Now in the prompt above that, above that,
line 18.
On line 18, it's molecular. What is the molecular?
Oh.
Yeah. All right. Okay. Now just copy those two lines and then ask for how many grams of that compound do you have? How many grams do you have?
I noticed a small error.
Yeah, sure. Go ahead.
Up by where it says double num molecules equals grams divided by molecular weight times Avogadro. Avogadro's missing an R.
Oh, no.
Wait.
That one was correct, I think. So DRO, not R-dro. No, there is no R before the D. No R before the D.
Oh, then the other one.
Things would have been much simpler if he had been if it just been named avocado, right?
Yeah.
All right. So you change the first one also. Avocado.
Yeah, I got fixed.
All right. Okay.
She
Good.
just fixed it.
All right. Excellent. All right. Good. All right. Now semicolon there. It's not molecular weight. It is grams. You accept input into grams now.
Yeah.
Right. Semicolon. Okay, and then now you're going to calculate it, right? So this intuitively feels like a separate paragraph for me. So give it a blank line before that. Right? Now you say num molecules equals count molecules underscore molecules.
Right now we're calling your function.
Yes, now you're calling your function. Now, the first parameter to the function you're going to pass is what is the
We
first?
want an open parentheses.
Open parentheses. And inside, you're going to give it two parameters. The first one is grams, and the second one is the molecular weight. Both
do I need to type double?
No. Double is just to tell the compiler that grams is something of family double, right? And then molecular weight, the type of molecular weight is a double. So we just tell the compiler, we don't have to tell it every single time. We just tell it when you introduce it.
I see.
All right. And now on the next line, you can say, cout, you have num molecules. Cout, yeah, left shift. And then you have num molecule. You have, and space, and then close the quote. And then now left shift, num molecules. No, now you just say num molecules.
Yeah, I got it.
And then left shift, and then space. Lots of people forget the space there. Space, yeah, and then molecules in your hand. Molecules of it, or whatever. Yeah. All right, and then an end out. Okay, all right. Now let's run it.
Don't forget the semicolon.
Semicolon. Let's run it and then try it for some substance that we actually know, right? Maybe iron or gold or something like that. And then go to Google and actually find out if we get the right answer or not. Yeah, how cool is that? All right. Now, while now someone else open a browser and what's going on? Oh, semicolon on the previous line. Okay. Oh, wait, why is it taking this long? All right, when something like this happens, what I do is just hit cancel. Is cpp.sh. I don't even know where they are hosting this machine. So maybe in some country where You know, hit Control A or Command A in that window. Command A, Control A. All right, copy that into your clipboard. Control C or Command C.
Yeah, copied.
Okay, now refresh the browser. Command R, Control R. Okay, now, oh, it actually got it back. Oh, see, it got back the old version. It didn't get the one that you fixed. Yeah, now run it. No, kill it again, yeah. No, don't, just same place. Just do a refresh there, but refresh there, and then what you do is just replace the contents of that window. See, it can't be reached. That's why I couldn't do it before. But you got it in your clipboard, so don't worry. So just go to some other online compiler instantly, right? We'll do that in 20 seconds. Just type online compiler on in your URL bar, online C++ compiler. No, this is not going to work, right? cpp.sh just bailed out on us, right? Just on online compiler. Just type, yeah, enter. Hit the first one. Doesn't matter. Hit the first one. All right. Yeah, just go into that window and then hit Command A and paste it. Yeah, Control A, get rid of the whole thing and paste it. You got their own header and everything, right? Get rid of all that too. Okay, all right. Now, what is this? Online CDB, GDB? How do you run this? There must be a run button somewhere. Is there a run button?
Yeah, I just clicked.
Oh, you clicked it. Where's the output?
Yeah, here.
Why? But oh, there you go. All right. No, before you type anything in, let's pick an element. What is everybody's favorite element? Mine is gold. All right. Okay. So, yeah. All right, Kenny, you're the author of the program. Tell me what is your favorite element?
Iron.
Iron. Okay. All right. Isaiah spoke up before you. Okay. Iron is in fact most abundant element on Earth. Right. Iron. All right. So iron. Let's say I have 5 kilos of iron. No. I shouldn't say 5 kilos. I have, let's say, 2 grams. 2 grams of iron. 2 grams. Just a needle, a pin. Right. 2 grams. 2 grams of iron. I want to find out how many molecules. How many molecules?
Wait, what is the? Wait, I answered the wrong question.
Yeah, I have 2 grams. Oh, I see. Right.
Yeah.
Okay. Now, molecular weight of iron. What is the molecular weight of iron? Someone can someone?
55.9.
Okay.
I'm looking at a.
Okay.
Looking at a weird source though.
Yeah. 55.
How about? Yeah, it's 55.4.
55.4.
55.4.
Yeah. It was 454, but 4 should do. Now, let's say I have 2 grams, right? How many? So take a guess. Damn it.
Sorry.
Okay, that's okay. I got 2. What is it? It looked like E to me. What is it? 2.7182818? No, it's a 2.17. Okay, all right. Okay, so we have. So now go to Google. No, don't close this window. Go to Google and find out how many atoms of iron are in 2 grams of iron. How many atoms of iron are in 2 grams of iron? Okay. Now let's see if we get the same number. No, you don't have to. Google will automatically parse it and do the right thing. Atoms, iron. No. How many atoms of iron are in 2 grams? How many atoms are in 1 gram? Oh, well, okay. Oh, 2 grams.
It's close.
What is it? What is 1 gram of iron? No, what is the value for 1 gram of iron? We can just double it.
1 times 10 to the power of 22.
Oh, 1 times, so 2 grams is 2 times 10 to the power of 22, right?
Yeah, we got 2.17.
Hey, cool. That is really cool. All right, so there you go. Now you can just run that program on your phone and you can go to any party and say, hey, anybody got any elements? I can All right, okay. All right, thank you,
I think
guys.
a more intuitive.
Yes, hey, Mark.
I was just going to say that I think a more intuitive test would be to put the same number twice for input, and then you should get 6.023 E23.
Oh, yeah. That's really cool. Yeah, try that. Yeah, try what Mark said is to basically say that you have 1 mole of iron, which is 55.454. What is it? 454 grams of iron. Yes. So say that you have 55. Yeah. All right. No.
So you'd have to run the
Yeah,
program.
you have to have 55.454 grams of iron. Yeah, run it again, and you should get Avogadro's number. I wonder why it takes this long. Yeah, so 55.454. Is that the number we saw? Yeah, we use 4.4.
Why my
As long as the number is the same, it kind of doesn't matter. Right?
Yeah, it doesn't matter. But yeah, 55.4.
My number pad, it's not working. Oops, connection is lost.
Oh, so maybe it wasn't cpp.sh. Maybe it was your computer. Right? No, it is possible that your internet connection was patchy.
Yeah.
All right.
5.4.
Yeah, and then say 55.4. So what is 50 squared? 50 squared is 625, right? No, 25 squared is 625. How could 50 squared? 50 squared should be 2500 something, right?
Anyways, put 55.4 and you should get 6.023 at the end.
How is that possible? Because 50 squared is 2500. So 55 shouldn't be much off the mark.
Yeah. You put the gram and the molecular weight. So this would be canceled out. I see.
Oh, yeah. So I'm sorry. Yeah, obviously. Yes, thank you. It's really cool test. Thank you, Mark. Fantastic. Hey, awesome. So was this all useful? You guys? Ricardo, you good now? All of you? Okay, all right, fantastic. Thank you so much for humoring me today, and hopefully you had a good time. Yeah, and are you guys coming back on Thursday?
Yes.
Yes.
All right. Okay, all right. See you then. We'll do some more coding then. Okay.
On Thursday, can I show an example?
Yeah, sure, absolutely. Why don't you go first? You go first on Thursday.
I think everyone wrote something and they were waiting to go, and then this kind of derailed us.
Yeah, fantastic. That's great because next class everybody can go.
Yeah,
okay. We'll have something prepped for next class then.
Awesome. Thank you.
Thank you.
This is so cool.
I just want to apologize to Maxim for suggesting something that requires data structures that we haven't touched on yet.
All right. All right, I'll see you guys later. Yeah?
All right, have a good one.
Okay, bye.
Bye.